Ba-da. All right, and we are back and live, ladies and gentlemen. Welcome to the show here. I'm just still getting everything set up. I do apologize. I was doing some laundry. Let me get the chat up here. Do. Chat, what's going on, chat? How's everybody doing today? How's everybody's Sunday? I hope everybody's doing well today. We're just out here having a chill Sunday about the Watch This Opono series. I think this is gonna be a good one. So we're gonna have a good time here. Comment all the stuff that you guys want to comment. Uh, we're gonna have a good time. We're just waiting for some people to get into the chat. But as you can see, we are gonna be finishing up the Opono series, learning about this planet. And we had such a good time recently with like alien biospheres, things like that. I really feel like this is going to be a good extension off of some of the stuff we were doing off there. It's like another project where somebody else is doing something that's not the exact same. It's not the exact same planet and everything, but it is similar. And I do enjoy it. I like the mix of science, art, and also the creativity it takes to do this type of stuff. Like you're creating your own planet. You're putting all the stipulations in there. You're doing all the stuff. And I think it's a good exercise for the mind to even be trying to attempt stuff like this. So again, shout outs to the creator here, Project Opono. Again, just waiting for people to get into the chat, get into the stream a little bit. And then we're going to go ahead and get started. But again, I do hope everybody's having a good day. Hope everybody's having a good one tonight. Let me make sure I'm the right size on my camera here. What you guys feeling like? Right around here? Right around here? I would say somewhere around... Ooh, hold on. Even numbers right there. I like even numbers, ladies and gentlemen. And we ended on episode 4. So we should be on episode 5. So yeah. Let's go ahead and get started. Ladies and gentlemen, make sure you like, you comment on the video, you subscribe to Project Opono. Again, I know we got a couple of subscribers for him last time. Let's get as many subscribers to this user or this creator as possible. Again, he's making great content, and we got hey, what's going on? How are you doing today? I hope you're having a good Sunday. Riley, I hope you are having a good Sunday. I almost called you Ryan for some reason. I'm sorry. But yeah, we're gonna go ahead and get started on this. Had to give it a like before I even watched it. Boom. There we go. Get ready for for an hour-long episode. Yeah, we're getting ready for an hour-long episode. Again, this was supposed to start at 7. Again, I was still finishing laundry, things like that, so I did need to get this done a little bit later. But we're here. We're only 30 minutes late. I feel like that's still a good time. Oh, you're the Opono's ult account. Hey, shout out to you. And I actually had somebody earlier to tell me that their art was going to be in this video. If I can pull up the user's name. Hold on, let me pull this up. Because they did say that they were in this video. Just want to make sure to give them a good shout out here. Comments. Community. In episode 6. Okay. They're in episode 6. Gotcha. Cool. All right. Well, let's go ahead and get started on this one. Again, try not to spoil anything for me in the comments, but I want you guys to participate in the comments. So have a good time. Just try not to throw out any spoilers if possible.
Welcome back, fellow explorers, to Project Opono. In the last episode, we explored the freezing polar oceans of Opono. In this episode, we will cover the two weirdest ecosystems on the planet, the deep sea and freshwater. We will start our exploration in the deep sea. The deep sea is an extreme environment for life to be in. The crushing pressure, cold temperatures, and lack of light force the creatures of Opono to evolve wildly different ways of life.
Okay.
The deep sea is particularly difficult for plants. The lack of access to the sun means that photosynthesis in the depths will be nearly useless or all but impossible. However, some plants may be able to eke out a living in this extreme.
So just for anyone who may be coming in new here, so far a lot of the life that we've talked about has been like underwater life, but it's been a lot. It's pretty much an underwater jungle where everything is like a lot of the big, they have like whole tree things in there that are like super huge. They take out they block a lot of sunlight. They also have like a lot of like creatures at the top that are blocking a lot of the light coming through. So living in the waters in on this planet so far is a lot different than living in the waters on Earth. Not like extremely, but it is a different sights that you're seeing here, just because of the type of creatures and how the type of plants and everything so far, and even the creatures. They have a lot of sea creatures so far that have adapted to the lack of sunlight that comes through underneath the water here. So we're just continuing.
Extreme environment. Perhaps a particularly hardy relative of the Stellophyto evolves to grow around
plus the deep sea is obviously dark because of how deep it is, by the way.
Thermal vents. Hydrothermal vents are openings in the planet crust formed from tectonic activity. These vents spew out various chemicals that organisms can take advantage of. Perhaps these Stellophyto evolves to ditch their photosynthetic pigment and transition to using chemosynthesis.
Okay.
Chemosynthesis is a process by which an organism uses chemicals to make energy they can use to survive. These vent-dwelling Stellophyto may take advantage of chemosynthesis to allow them to survive in the deep sea, being one of the only plant clades to do so. We will call these strange Stellophyto the Ocrocotrono. They may grow up to 5 inches tall and form vast groves around hydrothermal vents. The hydrothermal vents, being a hotspot of nutrients and heat, may prove critical to many organisms, particularly the Panoplicima. These sessile filter feeders, living in the seabed, may be an obvious resident of the deep sea. In convergence with the Ocrocotrono, these animals may evolve to utilize chemosynthesis. However, these animals cannot chemosynthesize on their own. Instead, they partner with chemosynthetic bacteria. These bacteria may grow in the tentacles of the Panoplicima, and in exchange for the Panoplicima giving them a safe place to live, the chemosynthetic bacteria give energy to their host. These chemosynthetic bacteria come in a range of colors.
These are real things in life, like on Earth, because that's actually really freaking cool. And the way they have like a symbiotic relationship with like they're giving other people an opportunity to gain nutrients from ventilation systems in the deep sea, and all they're asking for is a little place to stay. Hey, I'll sustain you life. All I'm asking for is a room. You guys got a room at the end here. I'm at work. Hey, shout outs to you, bro. About to get off work. Shout outs to you, Anthrax. You're here. You're with us. We got Riley in here, who's also, the alt account for Opono. So we got Project Opono in the building here. The bacterial chemosynthesis. Okay, so the bacterial also range in color from white to green to purple, etc. I like the green ones personally. I'm a big fan of green. If you guys know me, I love the color green. So I would probably, if I was underwater in the deep sea, especially because, if I was going to be an underwater creature, I would be a deep sea creature. I would mess with these things.
Purple to red to green. So these Panoplicima may vary similarly in color. However, the heat of the water around hydrothermal vents may boil the Panoplisma's tentacles, so they may evolve a shield made of their shell to protect them from the heat. We will call these strange Panoplisma the Eliaspratza. They grow up to 10 inches tall and live for up to 5 years. Another way to get nourishment in
Is it just me, or is like Eliaspratza like a really cool name? It just sounds like a elegant name, if you will.
deep sea may come from a special event called a whale fall. This happens when a large creature dies and falls to the seabed. On Opono, this may most commonly happen when the Phalaenosoma or Limbrosoma die and sink to the ocean floor, either from old age, starvation, or other factors. The creatures most commonly found at these whale falls are the...
Shout outs to the dinosaur dude. I love this. I like this art here. It really gives you that feel, especially with the actual, like the dark tones on the side of it. I don't know if that's just like the actual editing or if that's how he sent it in. But either way, I think it does add a lot to it. Shout outs to that.
Acrysoma, Enedrusculi, and Diabrachid. These creatures may have representation in the deep sea due to this fact. Perhaps a deep sea relative of the Macrysoma evolves to...
Oh yeah, this is like the sea worm, like almost kind of like a sea cucumber thing. I feel like this one definitely would
feed exclusively on these whale falls. Due to the darkness of the deep, these creatures may lose their eyes, relying on mechanoreception to find the carcass. This gives these creatures an unsettling, creepy appearance due to their lack of eyes and pale...
Now, you say it gives them a creepy look, but I do have to tell you, they looked creepy before this. So, I just gotta let you guys know that this guy... It wasn't the lack of eyes that made him creepy. It was the fact that he was a underwater sea creature. I would have been freaked out regardless. Dinosaur Dude is also the creator of another project, spec bio project. Oh crap, Project Zero. Okay, hey, we gotta check out Project
skin
Zero.
Coloration. These creatures may congregate at these whale falls, either to feed or to mate. After mating, the female Macrysoma will find a nearby hydrothermal vent and lay her eggs, ensuring they are kept warm until they hatch. After hatching, the Macrysoma will immediately begin feeding on decaying matter, repeating the cycle of their parents. We will call them the Typhloskoliiki. They grow up to 2 feet long and live for up to 7 years. These creatures may be larger than their ancestors due to deep-sea gigantism. Deep-sea gigantism is a phenomenon on...
Okay, I think that may have been the voice that they're using for this one, but I'm pretty sure that is gigantism. So, you know, that just may be... I'm pretty sure they use like an AI voiceover for this one, which I actually saw like a post or something that said they're gonna start doing it with their actual voice. So, hey, shout outs to that. That's pretty freaking cool. Again, I'm good either way. I just know it. So for me personally, I that is funny to me. It is funny to me that he said that. But obviously, you know, that's just me thing. That's just a me thing.
On Earth, where deep-sea animals are typically larger than their shallow water relatives. Another creature that could be found crawling along the seabed is the Diabrachid. However, these creatures may change their body plan in order to be better suited for life in the deep sea. Due to the lack of light here in the deep sea, sight will be nearly useless. As a result, in convergence with the Typhloskoliiki, these Diabrachids may lose their eyes. These creatures' tentacles may be covered in thousands of mechanoreceptive hairs, allowing them to sense food.
Shoutouts to watermelon.
Mates, and danger. One thing to note about these creatures are the sails on their backs. This sail is lined with bioluminescent organs. The Diabrachid can control whether to turn these lights on or off. The result in them using their bioluminescence as a deterrent, flashing them on and off to disorient and frighten predators such as deep-sea Phtyairabachid and Souvlak azagoni. These animals may feed on the Okrokotrono and whale falls whenever they are available. Once every year, the deep-sea Diabrachids migrate into the darkest depths of the ocean, away from any predators. It is here where something majestic happens. The diabrachids all start flashing their lights in a mesmerizing pattern.
Oh, they're putting on the light show. Is this going to be like a mating thing? This seems like it's about to be a mating thing.
Display signals that mating season has started.
Hey, I called it. I'm not gonna lie. I know a mating call when I see one.
And then, after the light show ends, the diabrachids all release their gametes into the water in one massive cloud. This ensures that the next
Don't drink that water, ladies and gentlemen. Not at that moment.
generation of diabrachids are born. After about 1 to 2 days and the eggs form, the mother diabrachids will all die simultaneously, leaving the fathers to care and defend the eggs until they hatch. After the children hatch, the father will die due to not eating for the entirety that the eggs were being cared for.
Jeez.
The young
Hey, shout outs to the dad, bro. Giving your life so your kids can have a better one. Shout outs to you. Your death will not be in vain. We're going to tell your story to your children. Your dad made the coolest colors on his back when he was trying to mate with your mom. She was like, I saw another, she saw another guy, but he was like, those colors were too irresistible. Shout outs to this guy.
Diabrachids then venture into the waters of their parents, repeating the cycle. We will call these fascinating diabrachids the Typhlitiganida. They grow up to 1 meter long and
now that's a name. Typhlitiganica.
Fascinating diabrachids, the Typhlitiganida.
Typhlitiganica.
They grow up to 1 meter long and live for up to 15 years. Moving up into more open waters, we may find a surprising creature. While the Typhlitiganida crawl,
you know what? They are good parents. You know, right? Riley, they are great parents, to be honest. The best, you know, they sacrificed themselves for their children. Only the best parents do that. You know?
To new hydrothermal vents, there is another, more efficient way to travel to new areas. The diabrachids and their relatives are famous for being bottom dwellers. However, one clade among them stands out. The Epipetosoma are the only clade of diabrachids that possess a tail fin. However, this tail fin is only used to help bury themselves under the sand. But they may have an opportunity to move into more open waters thanks to a unique quirk of the deep sea. The crushing pressures of the deep sea may not allow creatures with bones to survive without some radical changes to their skeleton. This means that the Carchariapsari and Phalaenosoma may not have much of a presence in the deep sea. So perhaps a clade of Epipetosoma native to deeper waters evolves a new mode of locomotion. Currently, these creatures' fins are only used to help bury them under the sand. However, if the Epipetosoma fling their tail fin too hard, they may launch themselves up into the water. This may prove to be a better way of moving along the seafloor, so it may start to become their primary form of movement. Over time, these creatures may evolve a gas bladder which they can use to keep themselves floating in the water after they leap. This, coupled with moving their tail fin, may allow these creatures to evolve to swim. However, due to the way these creatures' bodies are, their tail fin may only be able to move up and down. This may result in them only being able to swim by moving their tail fin in up and down motion. To give them stability while swimming, their fin may split into 2 extra side fins used to control the creature's position in the water, along with providing more locomotive power. They may also start evolving a second pair of eyes for better depth perception. However, due to the lack of light in the deep, their eyes may not have any lenses. We will call these strange swimmers the Panicado. They grow up to 1.5 meters long.
Not having the lenses, I imagine, helps you absorb more light, like as much light as possible. Is that the case, chat? I'm assuming somebody in the chat knows this. We got a lot of smart people in this chat. Honestly, probably I'm gonna go ahead and say it. I have the smartest chat on YouTube. You cannot find a smarter chat than mine. Every time I have a question, they're able to answer it. They're a good chat. Shout outs to the chat, smartest chat on YouTube. So, let me know about that whole eye thing. It's the opposite, actually. Okay, gotcha. See, that's what I'm talking about. They were able to answer the question. I thought it was going to be a thing where it makes you able to absorb more light. Apparently, it's the complete opposite. It absorbs less light. The lenses help gather more light and form a clear image. Oh, hey, well, shout outs to lenses and your eyeballs. Um, yeah, so not having them is actually a pretty bad thing, guys. If you don't have lenses in your eyes, you know, I'm sorry. I'm sorry for you. You know, it's probably hard out there. You might be blind. Would they be blind, chat? Would they be blind if they didn't have lenses in their eyes? Like, now I said my chat is the smartest on YouTube. I never said I was the smartest on YouTube, but that's why I have the smartest chat. There's, it's like a symbiotic relationship between me and the chat here.
And live for up to 17 years. Traveling from one vent to another is a long and treacherous journey. While the Panicado and Typhlitiganida may be able to migrate from vent to vent, other creatures may start to hitch a ride on them. Perhaps a small clade of the diabrachids evolves to cling onto the backs of these larger creatures. Their tentacles may split at the end, evolving into...
They wouldn't be fully blind. They would just see very blurry images. Well, you know what? As a person with glasses, I do understand that. That's almost my daily life. And you know what? Even with having glasses, you look at these computer screens all day. One of my eyes is definitely getting worse now. I'll tell you that. I'm pretty sure it's the left eye. This one's getting a lot worse for some reason. I think I just look at too many screens. Work, entertainment, and then the YouTube stuff. Oh my gosh, it's I might need better glasses. I don't know. I might need to get the glasses with I'm pretty sure these will have the UV stuff on them, but I might need to get that doubled. I'm gonna just buy the Ray Charles glasses now just to see how it works. Just to see how they fit. If I look cool in them, I'll going blind might not be too bad.
Pincers.
Depends on how cool I look in the glasses.
These creatures use these pincers to cling to the skin of their host, so they aren't dislodged while they move.
Yes, I will get that checked out. Thank you, chat. I will.
When the host reaches a new hydrothermal vent or a whale fault, the diabrachid will let go of the host and begin to feed and breed with other members of its species. After mating, the female diabrachid will lay upwards of 5,000 eggs near a hydrothermal vent.
Okay.
This reproduction strategy is called arselection, where an organism reproduces in vast quantities in the hopes of few will survive to adulthood.
And also, I'm pretty sure this is something that adapts well to smaller creatures. So, like, smaller creatures are usually on that end where they're like gonna have a higher birth rate and also be able to give birth more times throughout the year than like larger creatures that tend to live longer but also have those longer periods between when they can and cannot produce children, and then when they do they got to raise them up and stuff.
For hatching,
it's a whole thing. Remember when we watched the last video and that one animal only lived for like 10 days or something, or like 7 days, but then every other creature that wanted to eat it lived for 20 years. Like, insane stuff.
The babies will immediately begin looking for a house to cling on to, allowing them to store what little energy they have left after hatching. We will call these small passengers the taxitsies. They grow up to 2 inches long and live for up to 3 years. The Parvipsari...
I ain't gonna lie, living up to 3 years, not bad. I was kind of not even expecting 3 years to be an option for them. Like, I thought it was gonna be like, I thought it would be like 6 months or something.
Being as adaptable as they are, may find a home in this extreme ecosystem. Unlike the Osteopinae, these creatures never evolved bones, so they may have an edge in colonizing the deep sea. However, this means they will face new threats they have never seen before, such as the Panicado. To counter the Panicado, these creatures may partner with bioluminescent bacteria. One clade of Parvipsari may evolve to house these bacteria in a special pouch. This pouch may provide...
Holy crap. This is actually really cool. Hold on.
Parvipsari may evolve to house these bacteria in a special...
First of all, this creature itself, it just looks cool. Like, you cannot look at this and tell me that this don't look cool. My autocorrect corrected host to house in the script. No, you're good. You're good. Because I feel like even when you say it's like hosted or houses it, like I feel like people would still understand the like house like your house, your obviously it may not be right, but I feel like contextually it still fits. But this creature looks super freaking cool, and then you see that what the ability of it is, and then you're like, whoa, this thing is gonna be a threat. My screen is black.
Pouch.
Oh, my screen is black. What's going on here? Hold on. Oh. There we go. Okay, you guys can see the screen, right? You guys should be able to see the screen now. Okay.
This pouch may provide protection evolvers may part before, such as...
I'm not sure how far back it went, so I'm just going to go back a little bit. But I have to say, that creature that we're about to see coming up is one of the coolest creatures I've seen so far. I really love
the Panicado. To counter the Panicado, these creatures may partner with bioluminescent bacteria. One clade of Parvipsari may evolve to house these bacteria in a special pouch.
Right here. Look at this thing. Love it. Enjoy it. I love this thing. I want this creature in my house inside of a deep sea tank. Though I don't think those exist. I just made it up just now. Let's invent these things so I can house one of these things. This thing's look incredible. I want this. And then I'm sure, look at these claws, these mandibles. And then look, it's about to absorb bacteria in its pouch. And guess what? That pouch is going to produce light.
This pouch may provide...
Look at this. It's like a dark eye just looking at you in the middle of darkness. It's just like the eye of darkness.
Protection to the bacteria, along with a safe place to reproduce. In exchange for giving the Parvipsari use of their light, the Parvipsari may secrete a constant flow of nutrients into this pouch to keep their bacteria alive. However, these bacteria play a much more crucial role than just being a light source for the Parvipsari. They also can be used against predators. If threatened by a predator, the Parvipsari may start rapidly secreting hormones into its pouch. These hormones send the bacteria into a frenzy, making them rapidly turn their bioluminescence on and off like a light switch. This intense display may scare predators into thinking they are in danger, causing them to flee and leave the animal alone. Once a threat is no longer detected, the Parvipsari stops secreting the hormones, allowing the bacteria to rest and go dark for a while. This relationship between guest and host is called mutualistic symbiosis, where both parties gain something from each other in exchange for the other giving them something in return. The bacteria of the Parvipsari...
We were talking about, like, this is going over symbiosis. In the previous video, we also were kind of going over, like, different types of symbiosis. It's just such a coincidence that they're all, like, it's all coming together.
May range in color from blue to green to yellow and any color in between. However, once every year, something shifts within the Parvipsari. During mating season, the Parvipsari rise from the depths. They congregate under the moonlight and begin to breed. After mating, the female will lay her eggs along the coast before the group dives back down to the depths. After around 1 week, the next generation of Parvipsari hatch and start making their way down to the deep. Along the way, many are eaten, with the schools dropping in number, from 10,000 to 5,000 before they finally reach the deep. Once they reach the deep sea, the baby Parvipsari start producing that attracts the bioluminescent bacteria, making them fill their pouches. Once the pouch is full, it fully seals, giving the Parvipsari its own unique cultivar of bacteria. This gives every creature a slightly unique color. We will call these strange creatures the Thickalizer. They grow up to 1 foot long and live for up to 10 years. The deep sea is a tough environment with limited food. Coupled with the extreme cold and lack of light, predators here may need to evolve extraordinary adaptations to find and kill prey. Meet the Delirpsaria, descendants of the Souvlaki. These scary predators have taken up a niche similar to the anglerfish of Earth. One of their
Okay.
dorsal fins has evolved a fleshy lure at its tip, designed to lure in curious prey such as the panicato and thickalizer. They produce their bioluminescence on their own, not aided by any bioluminescent bacteria. Once prey is right in front of the glowing lure, their gate is sealed. With a lightning-fast motion, the Delirpsaria stabs its prey, killing it instantly. Their to lower jaw tentacles have become heavily muscled, allowing them to tackle the largest of prey, like the panicato. Their tail fin has evolved a tail spike to allow them to achieve bursts of speed to catch speedy prey such as the thickalizer. These creatures also use their lures to attract mates. By flashing their lights, they can seduce a partner. If the potential mate responds in tandem, mating is initiated. Once laid near a hydrothermal vent, the eggs of the Delirpsaria are abandoned by the parents. After about a week and
I'm not gonna lie, I feel like laying them next to a vent might be a better idea than putting them next to the shore. I mean, that's just me though. You know, if I'm an underwater creature, hey, Anthrax is off work. Let's go. We got the crab off work. Let's go. But yeah, I feel like putting them by the ventilation is just a better option. You know, if you're already underwater, you got to go all the way up. There's that pressure difference. You got to learn about. You know, it's a lot. You know, just put the eggs right there. But obviously, too late for those other guys. You know, they already made their choice. They made their choices in life. They got to deal with it.
half, the eggs hatch, giving rise to the next generation of Delirpsaria. They grow up to 2.5 meters long and live for up to 21 years. Their larger size is correlated with the abundance of prey they lure in, along with deep-sea gigantism. Returning to the dark and eerie sea bed, we find the Calbopla. These creatures are relatives of the Mecheiriodonta who have evolved to feed on the Iliaspratza and other deep-sea Panoplicima. To do so, however, they need a way to crack open their shells. To do this, their one-sharp, knife-like teeth have evolved into large clubs which they can use to shatter the shells of their prey. Once the shell is broken, the Calbopla feeds on its kill.
I could just imagine how this thing goes at people, where it just uses this big clubs, just like, yeah, just right on them, just cracks them like a
These
shell.
creatures use a unique quirk of the deep sea to hide from predators and prey alike. Red light is an extremely short wavelength. This means that it is absorbed by the water at much shallower levels.
Will I watch sky and plant color? Sure, yeah. Hold on. Let me just look it up here. This looks like the one. We'll add it to the list. There we go. Don't let me forget
Than
about
blue
that,
or
Jack.
purple light. The Calbopla took advantage of this fact, becoming a bright red color. Due to the lack of red light in the deep sea, predators appear black to organisms with eyes, such as the thickalizer. Their strange hunchback condition is due to the fact that their relatives used their tentacles like about to kill their prey. The Calbopla instead holds its tentacle out wide before curling its back up into a curve before rapidly relaxing those muscles, slamming into its prey. However, their clubs mean they can also feed on the bones of whale falls, giving them an exclusive food source that nothing else can use. This may allow the Calbopla to become extremely successful near the seafloor, allowing them to become the apex predators of the deep-sea ocean floor. They grow up to 2.1 meters long and live for up to 27 years.
Jeez.
Another deep
Good life over here. I thought they would have been. I didn't think they would be the apex. The apex. I thought that would have been the last guys. But still, my favorite is still the second one. I can't remember the name at this point.
seafloor predator may come from descendants of the Corallisoma. These creatures, which we will call the Yugonasongo, have evolved a hunting strategy similar to the Delirpsaria. They possess bioluminescent strips on their tentacles.
Hold on.
They don't make their own light, however, as they employ the help of bioluminescent bacteria. Similarly to the Thickalizer, the
Yeah, the
Yugonasongo
Thickalizer. This is my favorite, personally.
provide protection and food for their bacteria, and in return the bacteria give the predator use of their lights. These creatures' shells have evolved to be made of flexible chitin to allow them to move easier to catch their prey. To capture prey, the Yugonasongo contracts its body and tentacles, making itself shorter. Once prey such as the Thickalizer comes to investigate the glowing red lights, the Yugonasongo rapidly makes itself taller again. Immediately after, its tentacles stab the prey, grabbing it and dragging it into its large
Shout outs to the animation because it really gives the good visual. Also, why they gotta be killing Thickalizers, bro?
stomach. This hunting style is quite effective for the Yugonasongo. The filter-feeding hairs of their ancestors have concentrated and hardened at the tips of their tentacles, becoming to sharp dagger-like teeth which they use to kill prey. The Yugonasongo grows up to 1 meter tall and lives for up to 27.5 years. With the evolution of all these new predators, the Panicado may have to adapt. Perhaps one branch of Panicado evolves to hide itself from the view of predators. But how would they do this? On Earth,
Camouflage.
cephalopod's skin contains special cells called chromatophores. These chromatophores can help them change skin color. This is most common in shallower waters, but some species of deep-sea squid retain this ability. So perhaps these Panicado evolve millions of these chromatophores all along their skin. When not in danger, these chromatophores
Not gonna lie, can we imagine a world where humans have chromatophores that like actually change colors like this in life? I feel like things would be a little bit cooler. I feel like just like there would be a lot less just like add like random boredom within human society if we just had this, you know? Like if I could just change my hand to be like whatever color. Like obviously as a kid we all have that moment where we're like, whoa, I can't control my chromatophores. Whoa, they're going crazy. And it's like you gotta have like one of your parents sit you down. It's like, oh son, we all go through this, you know. And back when I was a kid I had the most embarrassing incident, and you know, I end up changing into the color of this, and it's like, whoa, at least I feel better. Thanks, mom. And then, you know, they all, you know, you all get help and stuff, you know. You're just like, oh, your chromatophore is going out of control. You're a teenager. Congratulations. That's normal. Like, we would have all been through that. Things would have been cool by the time you were like 30, 40. You would have been like, yo, I can go full camouflage whenever I want to. You know, I could, you see that rock over there? Watch this. Boom. Now I'm the rock. Nobody, you know, we might be able to change how we look structurally if we really try. Yeah, these are some good deep sea animals. I will say that. I can see why this is one of your favorites.
will make the skin appear gray.
I like this guy.
However, if a predator is spotted, the chromatophores rapidly shift from gray to red. As explained earlier, red light isn't very common in the deep sea. So these Panicado will be completely hidden from predators once their chromatophores shift to red, allowing them to quickly escape. These creatures may feed on the Ocrocotrono, Typhloskiliki, and Taxitses. We will call these color-changing Panicado the Iracomica. They grow up to 2 meters long and live for up to 23 years. While the deep sea may prevent creatures with bones from inhabiting it, it isn't implausible that a clade of Phalaenosoma evolved to live in the depths. However, they may make some radical changes to their body plan in order to be better suited for life in the deep. Their bones may become extremely light and flexible, allowing the Phalaenosoma to colonize the deep sea. However, due to the lack of the phytoplankton and micropene blooms in the deep sea,
you would have to be so careful of assassins in a Como human world, like a world where humans have like chromatophores and we could just change them in like eventually we're humans. I feel like we'd eventually just get better with it over time. You know, we'd learn the strats, the tags, all the stuff to make it as best we can, you know. Also, shout outs to the Black Hole Nerd for this art here. But you would have to be so worried about assassins. Like, so many people would be like, yo, you check every corner, everything, you know. Security alarms would have to be so crazy. You know, we'd all have those, we'd all have motion detectors everywhere. It's like, nah, we can't. You can't judge based off looks. Where's the thermal detectors? Where's the the motion and thermal together combined inside your house at all times? It's always on. It's like you would need stuff like that just to you know just to be cool. Because again, I feel like, and again, this might not be a thing, but like, what is contour, but just different, when they put all the makeup on and it's just different like textures of things on their face, you could probably contour your face to look like other faces, if you tried hard enough. If you just, there would be hella chicks that would just be like, oh man, I know how to contour my freaking chromatophores to make it look like I am a whole nother person over here, you know? And then maybe evolve it to the hair color too. Oh my gosh, society would be crazy. It'd be everybody getting catfished today. That's how it would be. Everybody getting catfished every other day by somebody.
Melanosoma may have to switch to another food source. They may evolve to feed around hydrothermal vents similarly to the Eliaspratza. However, their current feeding method won't be efficient enough. So perhaps the deep-sea Phalaenosoma evolved to move their filtering hairs off of their tentacles and into their mouth and throat. As this happens, their mouth may elongate into a trunk, giving them easier access to food.
Okay.
This gives them a wildly different appearance than their ancestral body plan. Due to hydrothermal vents being heavily spaced out, the large sizes of their ancestors may become detrimental to their survival.
Dang.
So these creatures may evolve to be smaller, to require less food. However, this may not provide them any protection from predators, so they may form pods of up to 15 individuals for safety in numbers. We will call these small Phalaenosoma the concuchi. They grow up to 2.5 meters long and live for up to 16 years. One of the largest deep-sea creatures on Earth are siphonophores. These creatures are massive colonial organisms made up of thousands of individuals who appear as one organism. Each individual animal is known as a zooid. These zooids allow the siphonophores to grow massive without worrying about any consequences except food and reproduction. Perhaps a strange clade of Daciosoma evolves into the niche of a siphonophore. However, one problem with this is that they are sessile. However, as explained in episode 2, the larvae of the Daciosoma are motile, swimming in the open ocean until they fall to the sea floor and mature. So perhaps another instance of neoteny occurs within the Daciosoma lineage. However, this time, the larvae may begin to congregate and form huge colonies in the deep sea. This may result in these creatures becoming the largest clade of deep-sea animal on the planet, with their maximum size being nearly endless. These colonies may be made up of thousands of individual zooids, each with their own role in the colony. There may be two dominant zooids in the social ladder, however. The zooids that take responsibility for feeding and reproduction are the most important zooids for the colony to protect, as they bear the role of helping the colony survive. The rest of the zooids make up the main body, housing the digestive system, circulatory system, and other organs. However, one fact about the Daciosoma is that their tentacles have...
If you were part of that, which, you feel like you'd be like a vital, like you're the food guy? Because I feel like I might not be like the food guy, but, also being like, what's another important part? Probably the tail, pretty important. That's probably like third or fourth on the list. Let's see. I mean, just being a part of the spine and the neural network and stuff is cool too. It's just like you don't want to be like, oh yeah, let me be the high priority part where it's like, oh, I'm the reproductive system, and then what happens if you're not doing your job? It's like, whoa, everybody's looking at you, like, whoa, bro, come on, what are we doing protecting you, bro? Don't make us separate from you, detach from you, and then get another. We can always replace you, bro. We got more people lined up for that job. The mouth guy, that's tough. That means sometimes you might have to run some offense. You might have to be the guy to get into the battle. Like, oh shoot, let me get away, bite. You got to know when to bite them and get away. You might not know. You're just you just got assigned to the head. You weren't like, oh yeah, I'm I always wanted to be the mouth. That was just part of your job assignment. So some people may not be ready for this. I'm just saying, before everybody just hop in and be like, oh, I'm definitely gonna be the mouth, definitely gonna be the reproductive organ. Let's give it give spine a chance. Give being part of the neural network a chance. It's all good stuff. Be part of the tail. The tail come in clutch sometimes. Be part of the part that makes it steer itself.
Eyes at the tips. This may mean that any segment with tentacles may also have eyes. Some of the tentacles may be broader, becoming fins, allowing the colony to swim slowly across the dark depths. However, as explained earlier, these tentacles, or fins, may have eyes on them, adding to the already strange appearance of these creatures. We will call these massive colonial organisms the Paraxipoi. They grow to a maximum of a few dozen meters long and live for up to 100 plus years. Moving up into shallower waters, we will now traverse the rivers and lakes of Opono. The rivers and lakes of Opono will be another habitat the organisms will have to adapt to. The fast currents of rivers, the murky waters of lakes, and the varying light levels form several distinct layers of life or microhabitats. In particular, plants in these bodies of fresh water will face a unique challenge in every body of fresh water they colonize. They will need to develop extraordinary adaptations to survive in these environments, such as tighter stems and shorter bodies. Perhaps a clade of Phyceophyto evolves to live in the rivers and lakes of Opono. Their main bodies are hidden underground, with only their leaves sticking out of the mud. Their soft leaves will allow them to bend with the current of rivers, allowing them to not be ripped out of the ground. These plants reproduce asexually, colonizing barren rivers and lakes very quickly, carpeting the river bed with mats of vegetation. We will call them the Kawakusa. They grow up to 1 foot tall. While the Kawakusa fill the role of ground vegetation, other plants may fill the role of large riverbank plant. This may come from a clade of Psilostele. These plants, which we will call the Ridicon, may grow along the riverbanks similarly to earth reeds. Their stem may harden, becoming almost woody. This is to help resist the strong river currents. Their leaves may also become smaller due to them being almost always...
Hey, shout out to Emporia. I don't know if he's supposed to have a smile on his face, but it kind of looks like he does. That's cute.
...in the air. Their leaves may evolve a thick waxy cuticle, along with stomata, to be able to stand the hot sun. With these adaptations, the Ridicon is well equipped to survive in muddy swamps and rivers, being the first clade of semi-aquatic plants on the planet. They grow up to 5 feet tall. The Kawakusa and Ridicon will form the base of the freshwater food web, paving the way for the animals to colonize fresh water. Meet the Porvoplavni, descendants of the Arfalu. These strange creatures have adapted to live in the rivers and lakes of Opono in several unique ways. They have increased in body length to easily snake through dense vegetation. They have evolved fin-driven swimming. Their first 2 pairs of fins have evolved into the primary locomotion.
Now, I'm not a fish expert here, but I do have to ask, are longer, elongated fish better at swimming in rivers? I didn't know this. I've never actually been fishing before, so is this something that's is bass are there? Are bass are they longer than normal lake fish? I don't know, river fish and lake fish. Is there a difference? I don't go fishing, bro. There's a lot of I'm sure they don't even have to be a scientist. I'm sure just a person who goes fishing would probably be able to answer this question here for me here. Are rivers usually filled with longer fish, and then ponds and stuff are filled with shorter, stubbier fish? I don't know. Again, I don't go fishing.
The fins, while the remaining fins have become ripped and tattered. These fins inhibit their locomotion, but greatly increase their hiding effectiveness, allowing them to blend in with their surroundings. Interesting.
Hold on. Sea snakes, eels, and the why can I not pronounce this? This creature here are longer to squeeze through dense vegetation. I feel like it was the paparoni, but it doesn't look like it's spelled that way.
Interestingly, their
Paparoni?
ancestral social hierarchy has evolved into something much greater. Their groups have evolved into harems. A harem is an animal group consisting of one or two males, a number of females, and their offspring. The dominant male Porvoplavny drives off other
Porvoplavny. I feel like if it looks like it should be Porvoplavny, but I don't know.
competing
I'm not a Porvoplavny.
males and maintains the unity of the group. If present, the second male Porvoplavny is subservient to the dominant male. However, if the second male Porvoplavny ever tries to mate with a female without the dominant male knowing, they too will engage in battle until one backs down or is killed. However, if one of the female Porvoplavnys are pregnant, the males will be fiercely protective of her and the eggs, attacking anything that gets within range, even plants that bend to
Hey, good dad right there.
close. Once the baby Porvoplavny are fully matured, they are exiled from the group to prevent inbreeding. It is at this point the males will start to form their own harems, and the females will look for harems to join. The Porvoplavny grow up to 1.5 feet long.
All right, now this is where you kind of lose me, where you're like, dang, I really hope I don't get a harem. And then all of a sudden you see your freaking sister in there. And that's like, oh man, wrong harem. Sorry, sis. You can't be in this one. Go up. I heard there was a guy up there, up the river looking for a harem. You got this, sis.
And live for up to 11 years. Another herbivore may come from a generalist clade of Ramphistodontia. These creatures' transition to a more herbivorous lifestyle is a drastic one, resulting in their weirder appearance and smaller size. However, the drastic change in ecosystem.
This is an interesting viewpoint here. I like the switch. Shout outs to Jasper.
May account for this switch in diet, as there are no corallisoma to eat in the rivers. So, the freshwater Ramphistodontia may substitute their diet with plants, becoming full herbivores. With their powerful jaws and beaks, they may be able to feed on the stems of the Ridicon, being one of the only clades to feed on their trunks and branches. However, they won't pass up the occasional dead body or kawakusa. However, the murky waters may make seeing difficult for these creatures. Although their echolocation may help them find food, it may not be enough. So perhaps the eyes of these creatures evolve a tapetum lucidum. A tapetum lucidum is a layer of tissue in the eyes of some animals that help them see in the dark, and in this will help the Ramphistodontia see in the dimly lit murky water. This adaptation may also give them a creepy appearance, as the eyes will look like they glow in the dark. We will call these eerie freshwater creatures the Calamitragon. They grow up to 2 feet long and live for up to 17 years. Due to the abundant groves of plant life in the rivers and lakes, any different clades of herbivores may be able to feed on them exclusively. One such clade is the Agelidinopsari. Due to the large amounts of food, these creatures may grow larger, with the freshwater Agelidinopsari being one of the largest clades in the whole ecosystem, even outgrowing their underwater forest forms in size and weight. With this increased weight, their flippers may not be able to support their movements. So, the freshwater Agelidinopsari may evolve their flippers into true legs. To support these legs, they may evolve a skeleton similar.
Now, is this going to be the first creature that makes it to land? Once again, place your bets. What's going to be the first creature to make it to land, ladies and gentlemen? I am looking forward to seeing which one it is. I feel like this guy's in the running. This guy looks like he's about to be number one. He's already got legs. That's like the first step, literally. As a person who does walk on land every day, and I do have legs, I feel like having legs is pretty important in it.
To those of the Osteopinae of the open ocean. With this skeleton, the freshwater Agelidinopsari will be able to walk along the riverbed in search of food and mates. Their legs will be splayed out to the side of the body, similar to earth lizards. Despite the inefficient posture, the lower gravity of Opono means that this style of walking is more effective than on Earth. However, it still may limit their maximum size and weight, although it still may allow them to grow quite large. However, not every pair of flippers may evolve into legs. Only the first 2 pairs of flippers have evolved into legs. The last pair of flippers have evolved into gonopods, structures used to latch onto mates during breeding. This gives the Agelodonopsari a quadrupedal stance, becoming the first clade of quadrupedal hexapinae on the planet. To be visible to one another, the freshwater Agelodonopsari evolve rings of colored skin around their eyes. The males only have one general eye ring color, neon green. The females, however, have more colorful colored eye rings, being anything from blue to green to purple. This is an example of the simplest form of sexual dimorphism. Sexual dimorphism means that there is an observable difference in physical characteristics between males and females of the same species. They may also advance their ancestral breeding behaviors accordingly. In the ancestral Agelodonopsari, the males and females exhibited different social behaviors. The males were solitary, while the females congregated in maternal herds of 7 individuals, not including their calves. This may eventually develop into a more advanced breeding system. During mating season, the males will group together into large congregations or leks and compete with one another in view of passing groups of females.
Hey, shout outs to the fairy ring. I like it's like you see some you're just walking by, you see a group of girls, and it's like you and your buddy just look at each other like, let's go. Come on, bro. Come on, see if you can take me. See if you can take me. See if you can take me. And then the chick, they're looking at us, right? Yeah, they're looking at us. All right, see if you can take me, bro. I'm about to take you down, bro. And then they're just going at it right now. And these chicks are just like, that guy looks good, pretty good. Oh, I like the way he's fighting right there. Oh, and this would just be how it is.
If a female
That's
is
hilarious.
impressed by a specific male, she will send out a call while making eye contact with a specific male she chooses.
That would be so creepy to hear in real life.
Male then responds.
Let's hear that one more time. She's looking at you, and she gives you this call. You going over? That's like the hey, come on over. Nobody's. I'm just chilling here. You're looking pretty good right now. Just want to see if you wanted to, make babies, and then this is the sound they make.
The male then responds in tandem and then initiates a mating ritual. After mating, the female will hold an egg sac in her gonopods, keeping her young safe until they hatch. After the egg sac hatches, the father Agelodonopsari will start bringing food to the baby Agelodonopsari until they are developed enough to survive on their own, at
Good fathers, good dads. Hey, good parents right now.
which point he will abandon the mother and her calf.
Never mind. Actually, he's a deadbeat dad. Actually, he doesn't pay child support. He's just like my father, for real.
This mating system is known as serial monogamy, where a pair of animals stay together for their entire life to raise young up until the young mature enough, in which one of the parents will then leave. We will call these giant...
Your dad divorced your mom right after you, it's like growing up with your dad your whole life, and then they get divorced, and it's like, whoa, what? Were you guys just waiting for me to go to college, and then you guys immediately get divorced? Like, what's going on here? This is crazy. This is insane. Why you guys couldn't have made this happen when I was younger? Maybe make it easier for me? No, you guys waited. Everything seemed cool, and then you waited till I got older, went off to college, and then immediately got a divorce in my freshman year. Insane, crazy.
The Phytotacarida.
And now we got another family. Now I got a stepbrother. What's going on here?
They grow up to 4 meters long and live for up to 25 years. With the abundance of herbivores, predators are bound to follow. Perhaps a clade related to the diabrachids evolves into an ambush predator. They may hide their bodies under the mud with only their tongue and eye stalks sticking out of the ground.
Not gonna lie, this is a good strategy right here, because look at it. It looks just like the other plants, but then it comes out and gets you.
One interesting feature of these predators are the 3 fleshy spikes on their backs. These spikes mimic the shape and color of a kawakusa, luring in hungry herbivores such as the porvoplavny. Once the prey gets close enough, they strike, impaling their prey on their tongue. They then drag their kill under the mud and begin to feed on it before getting back into position. We will call these plant mimics the Filipiso. They grow up to 2.1 feet long and live for up to 10 years. The panicado of the deep sea may find a home in the rivers and lakes of Opono. But due to the drastic shift in environment, their morphology may change drastically. Their eyes may...
Wait, Opono, are you in the U.S.? Because I noticed that it said feet there. A lot of times people use like centimeters, stuff like that. A lot of times we're talking to people outside of the U.S. So, shout outs to Opono if they are in the U.S. Shout outs to you even if you're not in the U.S. But, obviously, America, I'm American. I love America. If you are American, shout outs to you too, bro. Yes, you are from the U.S. of A, my brother. Let's go.
Evolve lenses to see in...
You understand what I'm saying? I saw he was like, yo, is how many feet? Whoa, feet. Hold on. I like that.
The brighter...
I like what I'm hearing there.
...waters. Along with this, they may lose their tail fin, instead using their side fins to swim through
Hold on. Are you in Ohio? I'm in Ohio. That's crazy. Ohio native right here. Shout outs to Ohio in the building. Ohio, Opono. Ohio means Opono. And, Opono means Ohio in family. That's a meme that I'm starting right now. If you've ever seen the Lilo and Stitch movies and also are in America and in Ohio, there's a lot of things that you would get from that would relate back to what I'm saying there. You just have to be an Ohioan.
Dense vegetation. As a result, they may lose their tail fin and evolve a body plan similar to the manta ray of Earth. To support their muscular fins, they may evolve a single cartilage skeleton. This skeleton may primarily be in the fins, giving them support. This has resulted in them having two spines, one on each side, with offshoots extending into the side fins. This makes these panicado the first diabrachids to have an internal support structure. This may allow these panicado to diversify massively.
Hold on, let's see that one more time, because he said he drew that skeleton. That's nice. Look, hey, yo, the creator drew this on his own, on a sheet of paper. I'm telling you right now, I couldn't draw this line. I would not be able to draw this line because I can't draw. I'm just really bad at it. So again, shout out. I like that you did draw out the concepts before even, because I thought you would have just put this on the computer. I don't know if it's needed to draw them out in person, but it's probably better to do that, right? I assume it's better to draw it out in person. And then
the side fins. This makes these panicado the first diabrachids to have an internal support structure. This may allow these panicado to diversify massively in the coming few million years. We will call them the actinocosin. They grow up to 2.6 feet long and live for up to 17 years. With the abundance of detritus and dead material piling up on the river bed, animals will start taking advantage of this untapped food source. One such animal is the ruca. These creatures are related to the Catharapsari of the underwater jungle. However, they don't possess the rattle of their ancestors. Instead, their upper tentacle has developed into an arm-like appendage. The end of this tentacle is split into 3 fingers, allowing the ruca to pick up food items and pass it into their mouth.
Shout out to the dinosaur dude. I like how they drew that out there. So it's like 3 little. Wait, does it have like little fingers on top of the fingers? That's
with the help of the 2 lower tentacles. However, this hand can do more than pick up food. They can use their hands to pick up and throw things such as rocks. But why would they do this? You see, these creatures travel in groups of up to 50 individuals. However, these groups aren't just for protection, they are for helping one another. These creatures are altruistic, meaning that they depend on each other for their mutual success. While the school forages for food, one stays behind to look out for danger. The lookout keeps a constant eye out for danger. If a predator is spotted, the lookout will pick up a rock.
This is like what meerkats do. If you guys are familiar with meerkat societies, it's like they're very much like a group where some people would be out looking for food and stuff, and then there's always one meerkat just like at a like perched up, just like watching the group, making sure like everybody's safe and like looking out for danger. And anytime they see some danger, they'll get a call. And then there's also like birds that do this for other creatures as well. It's like, dang, shout out to birds, bro.
It will then throw the rock at the rest of the group and let out a loud scream, warning the school of the incoming danger.
Not the loudest scream in the world, I'll say that. Don't get it confused for the mating of the other creature now. That might be a little embarrassing.
However, what use is the strategy if an individual skips its duties for a free meal? You see, being alone is dangerous for any lonely Ruka. Predators lurk everywhere you look, meaning there is a constant source of danger and death. So it is in the Ruka's best interest to do its duties to stay in the protection of the school. However, if an individual constantly skips its duties, the leader will pelt it with rocks, signaling that it has been exiled. Leaving the group is almost guaranteed death, so the individual will never be able to cheat the system again. These creatures grow up to half a meter long and live for up to 19 years. Another scavenger may come from yet another clade of freshwater panicado. Similarly to the Actinocosin, these creatures may differ significantly to their ancestors, becoming nearly unrecognizable. Their body may elongate, becoming ovular in shape. At the same time, their tentacles may go lower down the face to make grabbing food easier. These creatures' eyes may become smaller, being nearly useless. Instead, they may use a pair of sensory whiskers on their heads to find food. These whiskers will be highly sensitive, being more sensitive than a human finger. This allows the panicado to identify anything they find with ease, from food to mates to predators. These whiskers may also aid the creature in taste, allowing them to taste their food before ingesting it. These traits give the panicado an appearance similar to earth catfish. We will call these odd creatures the Geniano. They grow up to half a meter long and live up to 11 years. Another scavenger may come from relatives of the Typhlitiganida. These creatures, which we will call the Denphilosoma, mimic the leaf of a dead thallus philo to not be noticed amongst the leaf litter of the seabed. To appear as a more convincing leaf, their already flat bodies may flatten out more than they already are. The mechanoreceptive hairs on ends of their tentacles may elongate, evolving into hairy brushes the Denphilosoma can use to sift through the leaf litter for anything edible. Due to their lack of eyes, their mechanoreceptors will act as their sense of taste, their sense of sight, and sense of smell. If a threat is sensed, the Denphilosoma will rapidly shake its body, burying itself under the leaf litter. However, this may not be enough to deter the most persistent predators. So perhaps the Denphilosoma may evolve a form of toxin, more specifically poison. This poison may be contained in special glands evolved from old digestive organs no longer used by the Denphilosoma. This poison is then distributed into the flesh of their body, making every part unsafe to eat. This added form of defense will mean that the Denphilosoma will be left well alone, allowing them to forage among the leaf litter without fear of attack. They grow up to 2 meters long and live for up to 10 years. On the surface...
Now, I hope they have... they need some regen powers, regen abilities, some good ones.
Surface of the water,
somebody might still take a bite out of them,
may find species of the Tmimitos philo. These plants will be similar to earth lilipads. However, one issue they face is dispersal. The spores of the Tmimitos philo can't travel far outside of water, so wine dispersal won't be an effective strategy. So perhaps these plants evolve small, bulbous fruits at the ends of their roots. These fruits will be filled with a nutritious, sweet flesh, which is an irresistible bribe for herbivores. These fruits may contain the plant's seeds, which may be reinforced with an outer layer to survive the digestion process. Once eaten and passed out in the animal's excrement, the seeds will mature, floating to the surface of the water and maturing into an adult. We will call these fruit-bearing Tmimitos philo the Condylophilo. They grow up to 1 foot wide. As the condylophilo begins to carpet the surface of the water, the roots may start to tangle together into a thick mat. These root tangles will create the perfect microhabitat for a few clades of
It
animals.
might just be me, but I feel like this image took a minute. I feel like this image took some time to make. You know, I feel like it went detailed, and you got to draw all this stuff and then get all this. It feels like it took a minute.
Animals that can adapt to survive there. Perhaps the thickalizer of the deep sea may come to find a niche in this microhabitat. These animals may not be much different than their ancestors, with several major exceptions. Their top two tentacles may evolve dagger-like teeth at the ends, which they can use to spear the fruits of the condylophilo and bring them closer to the mouth. The second major difference is their lack of bacteria pouch. This is because the higher light levels of fresh water will allow these organisms to survive without their biological partners. Instead, that pouch has been repurposed. This pouch serves an important role in reproduction and the survival of the juveniles. This pouch, similarly to those of Earth marsupials, provides a place for the young thickalizer to develop until they are mature enough to leave it for good. However, only the male bears this pouch, similarly to Earth seahorses. Once the male...
No, there's no inhabitants on the land right now. It took... Oh, wait. It took over an hour and a half to draw. Oh, crap. I knew that was a detailed image. I knew it. Yeah, there's no inhabitants on the land right now for Project Opono. I believe that would be next episode that we're going to see that based off the title, which I probably should have not read, but I saw it in the playlist. I did read the names of the video in the playlist. I'm sorry. But yeah. Next episode, we should be seeing some land. But for right now, I do have a guess on who I think is going to be the first creature that makes it onto the land. We saw him earlier. He already has legs, already has a skeleton. They got pretty cool mating rituals so far. I forget the name of it, but we all know I have my guess already on who's going to be the first creature on the land. This is going to be a good one. We're going to see.
And female thickalizer have mated. The mother will deposit her eggs within the male's pouch. She will then depart to find another mate, leaving the male to care for the eggs alone. This is called male-only parental care, where only the male of a species takes on the role of caring for the young. As the eggs develop in the male's pouch, it will begin to swell, getting the male an almost pregnant appearance. During this time, the father thickalizer will barely eat, putting all of his time and effort into the eggs. After around a month and a half, the eggs finally hatch. It is at this point that the male Winzig will die.
Dang it, I had a feeling. R.I.P. to this guy, bro. R.I.P. to the dad. R.I.P. to another goat having to not eat and give all this nutrition for his child just for that child to survive. Shout outs to these parents. Some parents on land that, they would never. We all know at least one parent that would just never do this,
Having starved himself for his offspring. The juveniles, needing an early energy boost, will then devour the corpse of their father, giving them an advantage in the dangerous river.
Eating your father? You just were born. No. Okay, do what you gotta do, bro. Do what you gotta do. Just feels like maybe you have a creature that maybe kills another creature and puts its eggs inside of that creature so that way it has a fresh. You know what? Eat your dad. Go ahead. You be the person that eats their dad. Kind of. What did they do? Starve themselves so you would have food, and then as soon as you get born, immediately, you eat their dead corpse. You know what? Hey, you can only be so good of a dad. It is what it is at that point. This is nature. I'm just making jokes here.
They call home. However, after this point, they will only eat the leaves and fruits of the condylophilo. We will call them the Winzig. They grow up to 1.5 feet long and live for up to 9 years. Another creature that could be found in the root tangles are the micropinae. These small animals may be perfectly pre-adapted to life in this microhabitat and so may quickly colonize it. Pre-adapted animals are animals that evolved a body plan that may turn out later to be suited for a later environment. The small size of the micropinnae may allow them to easily dart between the gaps between the condylophilo roots. However, they still may be too densely packed to swim through. So perhaps the freshwater micropinnae become the second clade of animals to evolve legs. However, due to the
Yes, time for frogs. Wait, hold on. Did you just call this? What am I seeing? Like frogs? What are these frogs? What the hell?
lack of
Did
skeleton,
you just call that out? What happened there? I think
the
you did.
micropinnae's
Okay.
legs may be made of pure muscle. This is very inefficient and energetically demanding. However, the small size of the micropinnae coupled with the lower gravity lessens these constraints, allowing the micropinnae to get away with having no skeleton. These creatures' legs may allow them to walk along the roots of the condylophilo. However, they may need another way to get from root to root. So perhaps their back pair of legs evolved to be larger and more powerful than the rest. This may allow the micropinnae to hop from root to root in search of food. However, they may occasionally hop out of the water while trying to get to another root. This may cause them to become semi-aquatic to deal with being out of the water for short amounts of time. These creatures may take part in playful competitions. They may do this during their childhood by trying to see who can stay on their hind legs the longest. These competitions aren't meant to hurt the other's chances.
No, I feel like you do have to have a skeleton to be outside of the water and have a good time, right? You know, just to be out and have a good time, you should probably have a skeleton.
At finding a mate later in life. They are just a form of play for these creatures. These animals will feed exclusively on the fruits of the condylophilo. We will call these small jumpers the microltus. They grow up to 5 inches long and live for up to 5 years. The root tangle microhabitat is bound to have a top predator similarly to every other environment on the planet. This apex predator may come about from a clade of neotenous Panoplicima. The Panoplicima larvae, similar to those of the Daciosoma, are motile, swimming through the water until they find a placid stick and make a shell. However, if neoteny occurs in a clade of Panoplicima, they may be able to take up a life of swimming in and around the root tangles, searching for Winzig and Microltus to feed on. The tentacles of these creatures may broaden into fins
gosh.
similar to the
It's like a villain from dang, I forgot the name of the game.
event that occurs in some Paraxopoizoids in the deep sea. As their tentacles broaden
Chrono Trigger. This looks like a Chrono Trigger villain.
into fins, they may lose their role in feeding. However, they may evolve to slap their prey, stunning them. However,
And also, yeah, that's true. I just got reminded the gravity is lower, so you may not need a skeleton above water on this planet specifically. I'm thinking of Earth. You know, as a person, a resident of Earth, a lot of times I do think of it first, even when it isn't the main subject. So you know what? A lot of times I initially think of Earth, but that's just because that's where I'm from. You know, it's a pretty good place if you've never been there. If you're an alien watching this, or you are, you know, my bad, you're only an alien to me. If you are from another planet and you're watching this video somehow, shout outs to you, first of all. But also, Earth is just the place that I talk about the most because that's where I'm from. It's where I was raised. It's where everybody I know is from, you know? So I do use Earth as a reference a lot.
this slap will only stun prey for a few seconds. So perhaps they evolve a new way of making sure their prey can't escape. They may evolve 2 claws at the ends of their fins. These Panoplicima may also evolve an extra method of immobilizing their prey. They may evolve a form of venom. Venom is a biological toxin actively delivered by an animal through a sting or bite to subdue prey or deter predators, usually injected into their bloodstreams. These Panoplicima's venom glands may evolve near the base of the claws where, after they slap their prey, the muscles around the glands will contract, squeezing the venom out and into grooves in the claws. This injects the prey with the venom, which paralyzes the target and allows the Panoplicima to get the kill. However, as explained earlier, the fins have lost their role in feeding and restraining prey. So purpose the mouth of these creatures evolves into a trunk similar to those of earth elephants. This trunk will allow these Panoplicima to grab their paralyzed prey before swimming to the riverbed to feed on their kill. However, their shells pose a problem. Their shell is made of hardened minerals such as calcium. This makes it very heavy, rigid, and inflexible. However, instead of evolving a shell made of lighter and more flexible materials, they may instead evolve thousands of tiny air pockets within the shell itself to reduce its weight. All of these adaptations give these Panoplicima a body plan similar to the extinct armored cephalopods of Earth, more specifically the Ordovician Camerochreas. However, there's...
I think it's actually insane that we know about this. Like, it's actually insane that we know that we can even visualize this enough to like create this and be like, yeah, that was life on our planet before the life that we currently know on our planet, because it really does give extra validity to everything we've just watched in the previous video of this could be real, like on another planet. Like the things that we're talking about and seeing right here for Project Opono, if you think about it, they haven't just been randomly BS and stuff. This is all real science they're using here. Shout outs to Project Opono. Shout outs to Riley. I'm sorry, I gotta make sure to remember that name, because it takes a lot to think about this. Riley is smart as crap. Like, it's actually insane how smart they are. And also being able to formulate this and regurgitate it in a way where we can understand it is really cool. Like, it's a really great thing. And then, like, it just really gives all the validity to his concepts when I see stuff like this, where it's like real scientists have seen creatures and they analyzed it. They got an idea of what they look like and like how they worked. And like, bam, here's our image. But then Opono's like, you know what? Real. I'll take that. I'll use science and I'll create a life system on another planet and see how that works out. While only using real science. It's actually
more really specific.
Yes, they designed their world to be scientifically feasible. So this could be, like I said, there could be a world out there right now with the creature that's similar to at least one of these creatures that we've seen so far, maybe even multiple of the creatures we've seen so far. Between this and then like the alien biospheres, like, obviously we're going to be watching another one coming up soon. There are going to be like, there might be a planet out there that has at least one of these characteristics in it. One of these creatures may be very similar to one of the creatures we've seen, in one of these two projects here. You never know. And that's the exciting part about life and nature. It's designed to be realistic in a way that the planet could exist in real life. Honestly, I feel like it could. I don't see any plot holes so far in your game, buddy. I don't see any holes so far. It's looking pretty solid,
Typically, the Ordovician Camerochreas. However, there is one last issue to solve before they can fully take over the predatory niches of the root tangles. That issue is their eyes. The eyes of the Panoplicima were originally on the ends of their tentacles, but with their tentacles becoming their primary way of swimming and injecting prey with venom, their eyes may get damaged. To solve this issue, their eyes may migrate onto the main body. They may be positioned one on top of the other, with the larger eye on the bottom to spot its prey easier. This gives them an even stranger appearance, however it will still allow them to fill the role of apex predator in the root.
I assume they're going to have good depth perception with this setup. I imagine this leads to having good depth perception.
Tangle microhabitat. We will call these strange squid-like Panoplicima the Lolligatesta. They grow up to 5 feet long and live for up to...
Lolligatesta? I barely know her. Yeah, you guys get that one? Yeah, you guys got that one. You guys are like laughing on the other side of your screens right now after that one. I already know, I'm not even going to question whether or not you guys are laughing. That was hilarious. Prime comedy right there. This is what you come to me for. Barely Noah.
To 14 years. Back below the root tangles, the remaining predatory niches of fresh water remain unfilled. One such role is that of an apex predator. Perhaps a clade related to the Geniano evolves to become the apex freshwater predator. Being scavengers, the Geniano are already somewhat adapted to predatory niches due to feeding on dead animals. So a transition to feeding on live prey may be quite easy for them. However, they may still make several adaptations to suit this new predatory lifestyle, one of which being better eyes. The eyes of the Geniano are small, having lost the role of finding food to the sensory whiskers. However, being a predator puts a premium on good eyesight, as seeing prey is just as useful as finding prey. So perhaps the eyes of the Geniano enlarge, gaining the role of finding prey at a distance. However, as explained earlier, the murky waters of the rivers may make seeing prey difficult, even with larger eyes. So perhaps these Geniano evolve a new way to help them see their prey in the murky water. They may evolve a tapetum lucidum. A tapetum lucidum is a reflective layer of tissue behind the retina in the eyes that enhances vision in low light conditions. This can be seen in some catfish on Earth. The Geniano, being similar to catfish, may convergently evolve a tapetum lucidum, allowing them to see prey in the murkiest of waters. Along with this, their sensory whiskers may get more sensitive, giving them even better sensory information about the things around them. The whiskers may also aid the animal in tasting and smelling food, allowing the Geniano to take in information about the things it is eating. Another thing they may evolve is electroreception. Electroreception is an organism's ability to detect electric fields, enabling navigation, hunting, and communication.
Okay. Will they evolve to also get the electric where they can use it offensively?
In both aquatic and terrestrial environments. There are two forms of electroreception. There is passive electroreception, where organisms detect external fields from other living things or objects. And there is active electroreception, where an organism can generate their own fields and sense distortions caused by their surroundings. Both forms of electroreception can be observed on Earth. Sharks and rays use passive electroreception to find prey, while electric fish use active electroreception to locate objects. Perhaps the predatory Geniano opt for using active electroreception, using the electric...
Okay, this is the first step. They have it as active so they can generate fields. Next, will they be able to produce an actual, like, shock wave from it, of sorts? Will they be able to generate electric fields with their body? They can do the electric fields, but can they generate an electric force coming out of their body to harm other people? We'll see.
Fields around them to track their prey from a distance. And
I believe in you. Be this world's electric eel. We need an electric eel so far.
And ambush them. However, evolving active electroreception may require them to evolve an electric organ. An electric organ is a specialized organ.
Wait, those elephant fish are a cool addition. African biotope fish tanks. Okay.
That generates electric fields for communication, navigation, defense, and hunting. As they don't use the electroreception currently, they may take millions of years.
Do they have specific fish tanks for like deep sea creatures? Is this a thing? Do they have deep sea creature fish tanks? If so, how much are they? And if they're, also, who in the chat is donating for me to get one? Guys, donations. This is where I where I become the streamer that asks for donations all the time. Guys, donate to the chat. Here's the thing. I'll always tell you what I'm going to use the money for. I want to get a deep sea fish tank. I will be placing it somewhere around yonder, maybe even somewhere around yonder. And then in these locations, I'm going to have a deep sea creature at all times just looking at the stream. We're going to be streaming together with the deep sea creature. I'm not gonna tase the creature or anything like that. You ain't got to worry about me doing all the stuff other streamers be doing. No dog collars on the deep sea creature. I just want to have it, observe it, be looking at it constantly. Point to it, be like, hey, can I get your take? Maybe have a microphone next to it. It's not going to talk, but I'll make the words for it. We'll go back and forth sometimes. It'll be a whole thing. It'll be great content, guys. So donate to the chat, donate to the stream. All funds will be going towards a deep sea fish tank, as well as the deep sea fish. It depends on what I mean by deep sea. The deepest you can go legally. Let's say that. What's the, let's start for, let's just start by donating enough for me to get a normal fish tank, and then we'll donate more so I can level that up to a deep sea fish tank. Let's just start donating first, and then we'll figure out the logistics of it later. I feel like that'd be the best thing to do.
To evolve it on their own. So this may result in the looking significantly different than their ancestral form. Their electric organ may be located on their heads, giving them the best possible way of using their electroreception to offend their prey. However, they may also use it to stun their prey using their whiskers. They may store their electricity in their whiskers until they find a prey item to feed on. Once they find prey, they will whip said prey with their whiskers, electrocuting them. This stuns the prey, allowing the Genio to get an easy kill. However, to catch up to speedy prey, they may need other specialization for speed. These adaptations include the evolution of a dorsal fin and more powerful fins. These adaptations will allow the Genio to dart through the river with surprising speed, giving them the ability to catch even the speediest of prey items. This may give them the rank of apex predator in the rivers and lakes of Opono. Without any competition, the Genio are free to grow larger, becoming the largest predator in the rivers they call home. We will call these electric predators the Lystricmatia. They grow up to 6 meters long and live for up to 27 years. Meet the Austriacabuc, relatives of the Panoplissima. These spiky creatures have evolved into a niche similar to earth sea urchins. Their shell has evolved many spikes around its surface to deter animals from trying to eat them. These spikes are barbed, similar to the quills of porcupines. This causes the spikes to stick into the flesh of predators' mouths, causing extreme pain and swelling. For extra damage, to spiken on the front and back have enlarged dramatically and have a forked end to cause as much pain as possible. This sends a signal to predators that they are not an easy meal, allowing the Austriacabuc to feed without fear of attack. However, the Austriacabuc aren't exclusively freshwater inhabitants. These animals are native to the ocean, more specifically the seabed. Here they feed on marine snow and small plants. However, during mating season, the Austriacabuc journey to the rivers and lakes. It is here where they congregate.
I feel like I just found out recently about marine, what was they called it? Marine snow, or pretty much just flakes of just sea creatures and dust particles and just fish particles are just floating through the water at all times. And there's just whole, creatures that just live off that. Literally just off the scraps. Shout out to all those animals, bro. I know they don't get a good meal a lot. I'm sure sometimes they'll get a chunk of meat just randomly swimming down or falling down the water, and they catch it, and it's yo, shout outs to me. Shout outs to the random crab that's just walking around the seabed right now, probably hungry, and then a random piece of a fish that didn't get eaten by another animal just falls right into his lap. It's gotta feel like Christmas on, it literally Christmas Day for that crab. Shout outs. I hope, putting it in the air right now, I hope a random piece of fish particle or fish meat, just falls right in front of some lucky crab right now. Shout outs to that crab out there, bro. He's about to be eating good tonight.
In large groups upwards of 150 individuals. They then spew their gametes into the water, giving them the best chance to unite and form offspring. The larvae then make their way back to the open ocean over the next few days before falling to the seafloor and making their shells. However, how do these creatures move? On Earth, sea anemones are able to walk along the seabed with their suction cup. This helps them evade predators such as starfish. The Austriacabuc have evolved the same mechanism, flexing and pushing their muscular foot along the seafloor or riverbed in order to move to mating grounds, find food, or evade predation. The Austriacabuc grow up to 5 inches tall, while their spikes can grow up to 15 inches long. Species can be found all across the planet, although they are most common in rivers, the ocean floor, and in reefs. Not every predator is as afraid of the Austriacabuc's thorny shell, however. These animals are the reef-dwelling Schizimobrachid. These predators can crush the shells of the Austriacabuc using their claws, so perhaps they evolved to take advantage of this fact, leading to the evolution of the synthlivin. The claws of the synthlivin have evolved to be similar to the crusher claws of earth lobsters. They are heavily muscled and powerful, crushing even the strong Austriacabuc shells and spikes. They start off by crushing the spikes off of the Austriacabus shells, making them easier to grab onto. They then crush the remaining shell, exposing the soft flesh inside. They then scrape the Austriacabuc out of the shell using 2 dagger-like bottom jaw teeth before...
Hey, shout outs to Twigek? I can't pronounce that, bro. But yeah, he drew this by hand, obviously. I like this.
Discarding the shells to find another...
Almost like a shark creature, but not at all like a shark, but almost like a shark. But scarier than... unironically, scarier than a shark.
Austriacabuc to eat.
Like, I would rather see a shark than see
However,
this.
the synthlivin isn't a picky eater. Whenever Austriacabuc aren't around to eat, they will feed on Liligatesta, Microltus, and even Ridicon if desperate. This makes the synthlivin very adaptable, allowing them to feed anything they can get their claws on. This will give them an advantage in more competitive environments, allowing them to avoid competition with other predators such as the Lystricmatia. However, their life cycle is a peculiar one. During breeding season, the synthlivin will migrate out of the rivers and lakes and into the open ocean seabed, there they will then mate. The females will then travel back to the rivers and lakes and carry the eggs inside them for around 1 Earth month until they hatch within her oviducts. This birthing style is called
Some Nautica-ass fish. that was a funny comment, I gotta say. I like that one.
Ovoviviparity. In the last episode, we discussed how ovoviviparity evolved in the Arctic conostoma and limbrosoma as a way to keep the eggs safe from the cold. However, ovoviviparity in these synthlivin will be quite different. After the eggs hatch, the babies will begin to cannibalize each other similarly to earth, sand, tiger, sharks. This cannibalism will ensure only the strongest baby from both oviducts survive, giving them the hunting experience and survival instincts they need to survive their environment. After being born, the babies will depart from her mother and begin hunting Austriacabus and other small prey. The synthlivin grows up to 0.5 meter long and lives for up to 13 years.
Up until now, all life on Opono has been confined to the water. From the ocean surface to the deep sea, life is found in all corners of the ocean, but all of that is about to change. In the next episode, we will explore how some of the organisms evolved to live on dry land. Special thanks to the fan artists on Discord.
Yo, again, shout outs to the artists here. Let me make sure I can read the names. Dinosaur Dude, Jasper, Biology Dude. This one's kind of cut off here. I can't really read that one.
Who submitted fan art for this episode.
Watermelon, I remember you. Emporia, Average Avocado, I remember you. Blue Baz, I remember you. Fairy Ring, I like that one too. That one was a good one. Really gave some really good detail because I feel like seeing these, like the chicks, like the creatures here, come in and then the 2 guys just start fighting. In my mind, these guys were just chilling before this. Before these women came by, these 2 guys were probably having a good conversation about just, guy stuff. And then bam, now they're fighting.
You all helped make this video a lot better than it would have been without your help. Thank you for watching. See you in the next episode.
Okay, so we're going to do this one here. We're going to do this land invasion. And then the next one we're gonna do is this sky and plant color video here. We're gonna add that. Actually, yeah, just add it onto the queue. And then after that, we're gonna finish it out with another video here. There was one more I wanted to get. It was a project Zero. Yeah, Project Zero. I want to also do Project Zero tonight. So we're gonna do this Opono, for the finishing up with the land, and then we're gonna do the plant and sky color, and then we're gonna finish this out tonight with Project Zero. Okay. Episode 1. All right, we can fit one more thing in there. Okay. Not too long. Okay, we'll finish it up there. But yeah, let's finish it out. Hey, you made it. Let's go. But yeah, we're gonna finish this out. Also, guys, make sure you like, you comment, you subscribe, not only to this channel here, but to Project Opono. We want to make sure we give support to the creator, making a really great project for us. The thought, the ingenuity, like everything that goes into this, it's a lot. So, the artistry alone, just the artwork takes a lot. So let's show them some love, show them some appreciation. Make sure we are subscribing to the channel. Also, feel free to subscribe to my channel as well, on the road to 2K. Hopefully we can make it there by the end of this year. But even if not, we're just here for the vibes. Also, I did have to point this out. Shout outs to Project Opono, because the last video we just watched, it felt like there wasn't as much like music to worry about getting copyrighted with. And first video is still public, but it did get the copyright because of the music. I am so much happier because I feel like that may not happen in this stream. But again, we are watching other videos, so who knows? This one still may also get demonetized as well, but at least it's still open for the public, and that's the most important thing. People can still see the videos. So yeah, I like the musical choices in the last one personally.
Welcome back, fellow explorers, to Project Opono. Over the past few hundreds of millions of years, all life on Opono has been relegated to the water. From the shallow oceans to the rivers and lakes, life has conquered every part of Opono's oceans. However, there is still one environment left uncolonized. That environment...
Hold on, what was this? Project Rose? Creators are professional sports players, so it's on hiatus, but it could be cool in the future. I like that. Anthrax Crab, can you please comment there? Comment that on one of the posts on my channel so I can remember for that Project Rose. Actually, I keep saying that, but I'm already here. Project Rose. Is this the one? Hopefully this is the one. We're gonna save it for next time. We can do this next week. Your art's in this episode. All right, well, let's see it. I can't wait to see it.
Is dry land. But why hasn't it been colonized yet? You see, dry land is a tough environment for...
Yeah, it's a tough environment. Not everybody can live up here, We got some real goats up here, greatest of all time type animals and creatures up here. This is the Earth, but, we might have some humanoid creatures coming up here. And, where my vote's going to go for humanoid creatures. If I see a humanoid creature, shout out, that's my guy over there.
For organisms that don't possess the necessary adaptations to survive in. As of now, dry land is nothing but a barren wasteland of rock. Coupled with the lack of food and blaring sun, the organisms of Opono's oceans have no reason to venture out of the water. But that may soon change.
We need plants to come up here first. Once plants get up there, then we'll start seeing some Then we'll start seeing some other creatures.
Perhaps a clade of Photinostroma finds itself in the intertidal zones of the two continents of Mazi and Apovlidos. Opono's moon Paravu isn't as large or as powerful as Earth's moon. However, its gravity may still have a great effect on the cycle of the tides and the inhabitants of the intertidal zone. As the Photinostroma begins spreading along the coastal waters, overcrowding may eventually occur.
Very dramatic.
This may result in some Photinostroma
Jordan, actually, Jordan, is this you? Hey, I believe this is Jordan right here. Hey, shout out to Jordan.
populations growing on the rocks
Yeah, oh yeah, they're like moss.
below. Eventually, these algae-like plants may begin to grow further and further inland, becoming something similar to earth moss. Over time, their physical appearance may start to change.
Wait, was I right? Was it moth or is algae moths? Is it like the exact same thing? Did I just say the same thing twice?
Algae-like plants may begin to grow further and further inland, becoming something similar to earth moss. Over time, their physical appearance may start to change. They may evolve millions of tiny hair-like leaves, giving them a fuzzy texture. At the same time, their cuticles may thicken slightly to retain the water they gather during high tide, allowing them to leave the water behind for good and take up a life exclusively.
Hey, once again, shout outs to Jordan. We got Jordan in the stream as well. Shout outs to you, Jordan. If you ever want to send me some art or make, some art or send some art my way, I got an Instagram, Discord. I don't be on TikTok, but I have one. And all the stuff, feel free. I love artists.
On dry land. As these moss-like plants become more and more adapted to terrestrial life, they may eventually evolve simple roots. These roots will break down the rocks into soil, allowing larger plants to start taking root. We will call these moss-like plants the Chytrovria. They will reproduce asexually on the barren land, carpeting the continents of Mazi and Apovlidos in a layer of thick yellow fuzz. The newly formed soil may allow larger plants to begin colonizing the now less barren lands of the two continents. On the supercontinent of Mazi, descendants of the Condylophilo may be in a prime position to become full-time land dwellers. As the Condylophilo begin carpeting the rivers and lakes, overcrowding is bound to be an issue. As a result, some Condylophilo may begin spreading along the riverbank, burrowing their roots into the mud. This may prove to be an effective strategy to avoid being suffocated by other plants, so these Condylophilo may adapt completely for growing out of the water. However, these plants may need to solve some problems before they can colonize the land. Their leaves will constantly be exposed to the blaring sun, risking them drying out. So these Condylophilo may evolve toughened cuticles around their leaves with tiny pores or stomata covering the leaves to allow them to continue taking in CO2 and releasing oxygen. Another problem these plants will face is their height. These plants, being very short, may need to grow taller to collect some light. So perhaps they evolve to elongate their central bulb into a trunk. To stay upright, these terrestrial Condylophilo may evolve a tough, woody outer layer around their trunks to stay supported out of the water. This may also keep water trapped in the trunk, keeping the plant moist. The last issue these plants need to solve is reproduction. In the ancestral Condylophilo, the seeds of the plant were contained in fruits at the ends of their roots. In these new terrestrial forms, when the plants are ready to reproduce, they may grow a small flower which emerges from the ground. This flower will be the female gametangia. After the flowers are grown, the plant will then release their male gametes into the air. Once a male gamete lands on a female flower, the flower will die and a fruit will start to grow below the soil. Once the fruits are mature, they may poke out of the ground, emitting a sweet scent to attract animals to feed on them, spreading the plant seeds in their excrement. We will call these strange trees the Xenodendro. Species range from 1.5 to 2 meters tall. As the Chytrovira and Xenodendro begin spreading across the continent, it is inevitable that animals will evolve to feed on them. Some animals in the intertidal zone may occasionally crawl out of the water to feed on the Chytrovira and the Xenodendro fruits. One such animal may be the Phorisosa. After the Phoresosa evolved, they quickly spread out of the reefs, spreading to almost every environment on the planet. Perhaps one clade of Phoresosa may find themselves in the intertidal zone. Here they would feed on the coastal Chytrivira and
I can't believe I was wrong about this. Like, the creature, they already had legs. They already had legs and skeletons. But then here comes this hook-mouthed bastard, become the first creature to get on land. Like, ruining my parlay, bro. Come on.
and other plants. Due to the lack of any other land animals at this time, these Phoresosa may be able to quickly spread across the inner
Here we go. This guy over here. Look at this guy. Now he's about to be the first on land. You don't even have legs, bro. What are you doing? Save that for the guy with legs. Let him go first. You're over just here like, oh no, I don't even care. I don't even need legs. I'll just move around by myself. Okay, bro, you'll just crawl around on land, become the first land creature. Congratulations, bro. You beat out the guy with legs. That lazy bastard.
intertidal zone, feeding
Get on your legs and get on the land, bro. What are you doing? You're letting this guy outpace you. He doesn't even have legs. You already had a skeleton.
on any plants and fruits that they can find. However, once the tide recedes and the pools of water these creatures find themselves in dry up,
Yeah, I get it. I'm just saying my parlay personally was for the other creature to be on there first. I'm very surprised because I forgot that this creature was like, it's not like I forgot it was a creature, but it's like I just wasn't expecting that one. You could have told me every other creature that wasn't like a plant, and I would have been like, maybe before this one. I just was not even expect. He just came out of nowhere with it. The last guy you'd ever expect.
the Phoresosa
Turns out he's got main character energy. Look at the main character energy he's got right there. It hits differently.
will be completely exposed to the air and blaring sun. When this happens, they may begin to dry out. However, these creatures possess a thick layer of skin similar to an exoskeleton. This may help them retain water, and so it may evolve to completely envelope these creatures' bodies. Along with this, it may evolve a layer of chitin for added defense. However, there are many other issues these animals may face. The snail-like foot of these creatures may not be an effective enough way to locomote on land. So they may evolve it into many pairs of legs, giving them a body plan similar to the centipedes of Earth.
Yep.
This change
Now he looks super scary. Now I don't want to be around him.
in
Look at this guy.
locomotion is quite drastic, so it may slow their transition onto land. However, their legs may not be covered by the exoskeleton. Instead, they may evolve thick leathery skin to retain water. The challenge of support due to the planet's gravity may be easy to counteract. Their main bodies may be supported by their exoskeleton, while the rest of the body is supported by a hydrostatic skeleton. This means they push and pull blood out of the limbs to allow them to walk around on land, similarly to Earth insects. The next problem these creatures face is breathing. The ancestral Phoresosa breathed using holes in between the segments of their exoskeleton. In these land-dwelling forms, these holes may lead to 3 pairs of lungs. These lungs may have a fractal-like internal structure to allow for greater oxygen exchange. These lungs may be helped in breathing by a large muscle positioned between each pair of lungs. These muscles may be similar to the diaphragm of Earth mammals. This gives these creatures a very strange but effective form of active respiration. As they breathe, the diaphragm contracts the lungs, helped by the lungs being pushed against the exoskeleton. At the openings of these lungs may be sent organs, allowing the terrestrial Phoresosa to smell the air to locate food, such as Xenodentra fruits, among other things. The last issue these creatures have to face is reproduction. Their eggs, similar to those of Earth amphibians and fish, have to be laid in water to not dry out. So these creatures may lay their eggs in the dirt to keep them moist, until they hatch and restart the cycle anew. We will call these strange Phoresosa the Tetradacopodia. Sizes range from 1 inch to over a foot long, and they live for up to 7 years. Another animal that may take up residence on dry land is the Phytotacarida.
A foot long is crazy. And also, here come these guys. Here come these guys, number 2. You're supposed to be number 1, but you know what? I'll forgive you. It is what it is. Too late now, though. You don't try to come impress me now. I already, the other guys already made it there first. But, shout outs to you for making it.
These animals may have a quicker transition onto land for a few major reasons. One reason is that they are already semi-aquatic, feeding on the Ridicon of the riverbank. Another reason is that they possess a skeleton. This skeleton first evolved as a way to support their weight.
Hey, shout outs to Project Cimatera. I know I mispronounced that, but yeah, shout outs to you, bro, for making this.
In the water. However, it may allow these creatures to walk on land. As they specialize for life on land, their physical appearance may change. Their head may part from the main body, as their current position has their front pair of legs connected to the skull, which isn't that great for a terrestrial animal. As this happens, their legs may be positioned further and further down the body, eventually evolving an erect posture to bear their weight. However, there are still issues these animals need to solve, one of which being water retention. These creatures, descending from semi-aquatic animals, may already have thick leathery skin. However, as they move further inland, this may not be enough to bear the heat, leading to dehydration. So these creatures may evolve a new type of skin. They may evolve scales. These interlocking scales may protect the animal and also have the added benefit of retaining even greater amounts of water. The remaining issues these terrestrial Phytotacarida have are breathing and reproduction. The Longacauda from which these creatures descend had gills under their first two pairs of fins. These gills may be internalized, forming into two pairs of lungs. However, these lungs will be very different from ours. These creatures' lungs may have two openings and one exit. The intake pipes may be positioned at the top of the body to allow them to easily take in oxygen. The outtake pipe may be positioned on the sides, allowing them to exhale the air and not breathe it back in. To aid them in taking in air, they may evolve a pair of breathing muscles for each lung. These muscles may operate separately from one another. This may mean that as these creatures exhale, they may draw in new air, allowing them to have two batches of air in the lungs at the same time. To be able to smell, they may evolve scent organs at the openings of their lungs, forming their sense of smell. In the case of reproduction, they may evolve a remarkable form of keeping their embryos from drying out. These creatures may evolve to house their embryos in a thick leathery egg sac. This egg sac may be filled with water and many yolks to feed the developing young. The gonopods of these creatures may strengthen, allowing them to carry their egg sac around as they feed, protecting them from threats and the elements. When the young are about to hatch, the mother will lay the egg sac down in a simple nest made of mud and rock. After hatching, the mother will bring her young food until they are developed enough to feed on their own, after which the mother will abandon them to fend for themselves.
Dang.
We will call these animals the Onoperitillus. They grow up to 2.5 meters long and live for up to 15 years. These creatures decrease in size and lifespan is due to the drastic changes they have undergone while transitioning onto land. And now we will travel over to Apovlidos to continue to expand the terrestrial ecosystems. The Chytrivira of Apovlidos may create new soil similar to the soil of Mazi. This soil may allow new plants to grow on the land of Apovlidos. These plants may come from relatives of the Kawakusa who still have an above-ground stem. These plants may face challenges similar to the Xenodendro of Mazi. As a result, they may convergently evolve some of the same adaptations as the Xenodendro. The stem of these plants may evolve a thick woody outer layer to retain water and support the plant. Their roots may burrow into the soil, allowing the plant to take in nutrients and anchor it to the substrate. And their leaves may evolve toughened cuticles and stomata to allow for water retention and gas exchange. However, due to the smaller stature of the Kawakusa compared to the Condylophilo, these new terrestrial forms may only be around half the height of the Xenodendro. In the case of reproduction, these plants may evolve to grow two branches once they reach maturity. The male branch will be more rounded and bulbous, allowing the gametes to be expelled in a puff of pollen. The female branch may be cup-shaped to allow them to collect as much of the male pollen as they can before forming seeds. These seeds are then released into the wind to hopefully carry them to new places for them to grow and mature into an adult. We will call these short trees the parvucormo. Species range from 0.75 to 1.25 meters tall. One animal that may be found swimming along the coasts of Apovlidos are the parvipsari. These adaptable creatures may be attracted to the shores by the numerous dead bodies that are scattered across it. As they specialize to feed on these bodies, their fins may evolve into 6 bulky, muscular legs. These legs may be supported by a simple hydrostatic skeleton similar to that of the tetradecapods. As the parvipsari spend more and more time on land, they may begin to breathe air. They may do this by internalizing the gills under their first set of 2 fins into 2 lungs. These lungs will have one opening and one exit. This means they inhale through one hole and exhale through the other. These lungs may be aided by large, diaphragm-like muscles contracting and expanding the lungs to help these creatures breathe. They may evolve specialized scent organs near their intake pipes to allow them to sniff out their food from a distance. To not dry out on land, they may evolve a thick leathery skin. This skin will be similar to that of a cow, allowing the parvipsari to retain water as they transition to a fully terrestrial lifestyle. The last issue these creatures face is reproduction. Their eggs must still be laid in water to prevent them from drying out. However, unlike the tetradecapods, who simply bury their eggs in the soil to keep them moist, these parvipsari may protect their eggs by evolving a soft leathery outer casing around them. This will keep them from drying out in the blaring sun, but will allow them to be flexible enough to not be damaged if they were to get hit by anything. This will allow the parvipsari to take up a life completely independent of the water. But why would they do this? You see, the oceans of Opono are teeming with life.
Yeah.
Everywhere you look, there is life in all shapes and sizes.
But if they go to the land, now you're a dominant creature. Now you're apex, or you get a chance to be. There's only like 4 of you up there. It's like 3 people and some plants up here. Like you could be the king around here. You know, if you play your chips right. You know.
This may present large amounts of competition for the parvipsari, and so may incentivize some groups to take up a fully land-dwelling existence. We will call these creatures the Sispotas. Sizes range from 2 inches to just over a foot long. They can live for up to 7.5 years. As the Sispotas begin to diversify on land, predators are bound to follow. Perhaps a clade related to the Loligatesta evolves to feed on the Sispotas and anything else they can get their tentacles on. To stave off dehydration, these creatures may evolve a thick layer of skin similar to the skin of earth reptiles. As these Loligatesta begin to crawl out of the water to feed, their tentacles may be their primary way of getting from place to place. Over time, the Loligatesta with the strongest tentacles may have better locomotive efficiency and so will be more successful in colonizing the land. Over time, their tentacles may strengthen into legs, giving these animals a bipedal stance. This may mean that
Wait, how tall is this thing again? Why does this thing look like it's towering? Like, it looks like it's like gonna be like 20 feet tall. I have a feeling it's probably like I feel like this is probably like not 20 feet tall, but it looks so tall. Yeah, land squids. Yeah, land squids are a thing, but like this looks crazy. This looks scary. Well, I'm not saying they're a thing, like they're a real thing, but like I've never seen one. But who knows? I don't know. I don't know enough about squids. But still, this is crazy. This thing looks. How tall is this thing?
Trunks may be the only way they can grab food, such as the Sispotas. However, these creatures have no skeleton, so how do they support themselves on land? Over time, their shells will segment, allowing for greater flexibility and speed. As this happens, the sides of the shell may grow lower and lower down the legs. This may help support the legs, and so may be the key to keeping these creatures upright. The shell on their legs.
Hold the freaking phone. So these things have an exoskeleton going around their entire body that also covers up their legs, and now it's giving them support. That's actually insane. Like, what the hell? This is crazy. I drew them on a small canvas. The size comparison is at the end of the video. Okay. Gotcha.
legs may segment, allowing for more leg flexibility and greater walking efficiency. As a result of their new support mechanism, they may have something similar to the spines of Earth vertebrates. However, as these vertebrae are on the outside of the creature, they may not be called vertebrates. Instead, we will dub these creatures exovertebrates. The final issue.
They're like the vertebrates, but they like to go out and they like to socialize more than normal vertebrates. You know, they're really cool. They're verticate. You guys know the joke I'm trying to get here, right? You guys get it. You're a smart audience.
Creatures may need to solve are breathing and reproduction. As for breathing, the ancestral Panoplicima from which the Loligatesta descend breathed using a set of holes under the top portion of their shell, just below the tentacles. In these land dwellers, these holes may lead to one giant, segmented lung. This lung may be covered with ridges and bumps to maximize surface area. In between the segments may be to diaphragm-like muscles used to squeeze air out of the lungs through one central tube and pull air in through to intake tubes as the lung expands again. Near the openings of the breathing tubes, to scent organs may evolve, forming the sense of smell for these creatures. The final issue they face is reproduction. To not dry out on land, the eggs of these creatures may be lined with a thick calcium shell similar to the eggs of earth birds. Inside this shell is water and a large yolk. The water keeps the embryos moist, and the large yolk provides the developing young with nutrients until
Is it just me, or do you guys also think of like Bill Works in these situations where it's like water in the egg on the land, baby in the water, in the egg, it's like bye-bye oceans.
They are ready to hatch.
I think about that so often.
However, in the ancestral Dakiosoma, the reproductive organs were connected directly to the stomach as they had a blind gut. In the Loligatesta, this may mean they have to expel their eggs through their trunks to be able to lay them. In the land dwellers, this may be detrimental, as if the egg were too large, it may rip the mother Loligatesta's trunk, decreasing her feeding ability. So perhaps the digestive system of these creatures evolves a partition of the throat where waste can be excreted and the eggs can be laid from. This may mean the digestive and reproductive organs of these animals may be under their tentacles. To reproduce, the Loligatesta may raise up their partner's trunk with their own and exchange gametes with a kiss. The father will have a simpler reproductive system, only being a small tract connected to the throat. The mother, however, may have a large cavity behind her reproductive tract in which the eggs can develop before they are laid. After mating, the mother will lay 3 to 5 eggs in a nest made from Chytrovria. After hatching, the young will immediately begin feeding on their nest before leaving to embark on their own journey. Okay. We will call these strange bipedal animals the Panoplopodia. They grow up to 2 meters tall and live for up to 17 years. As the plants and animals begin to colonize the...
Hold on, wait, what was that? How?
For up to 17 years. Panoplopodia. They grow up to 2 meters tall and live for up to 17 years. As the plants and animals...
So this thing could be like just taller than like a human. I'm pretty sure like human is like 1.7 meters average. Okay.
Begin to colonize the land, their dead bodies may start to pile up. This may be an excellent source of nutrients for a relative of the Typhloskoliiki who already feed off of the dead bodies of larger animals. So the buildup of dead bodies on land may push a clade of Typhloskoliiki onto land. As they rise from the depths, their morphology may change drastically. Their bodies may get smaller and thinner to deal with the decompression. Over time, as they become more and more adapted for life in brighter waters, they may re-evolve their eyes. However, these eyes will be tiny, only allowing them to see blurry silhouettes of food and mates. As they spend more and more time on land, their skin may thicken to retain water. However, there is another way to keep from drying out on land. On Earth, earthworms have evolved to burrow into the soil to stave off dehydration and avoid predation. So perhaps these terrestrial Typhloskoliiki evolved to burrow into the newly formed soil, keeping their bodies wet and out of the blaring sun. As they evolve a burrowing lifestyle, their body shape may become more suited for digging. The ends of these creatures' bodies may become pointed to allow them to cut through the soil. This is called fossoriality, where an animal's body evolves to be suited for digging. Fossorial animals will usually have a fusiform or pointed oval-shaped body, along with reduced structures such as arms, legs, and tails. These Typhloskoliiki may retain their tentacles. However, they may shrink as they lose their role in digging. Instead, their tentacles may gradually evolve into structures used to help them smell and taste, using their ancestral mechanoreceptors to probe at food. These animals, being small enough, may breathe through their skin similarly to earthworms. This means they will have to exit the ground for a short period of time to be able to take in oxygen. If they don't exit the ground every once in a while, they may suffocate and die.
Dang.
We will call these creatures the Terravermis. They grow up to 6...
Bro, imagine suffocating and dying after you buried yourself down there. Like, kind of insane, right? It's kind of like insane work. Like, you did this to yourself. How am I going to help you?
...inches long and live for up to 2.5 years. They will inhabit both Mozzie and Apovlidos, similarly to the Chytravria.
And thus begins a new era of life on planet Opono. From humble beginnings as small, fish-like creatures, weird anemone-like creatures, and yellow algae-like plants, life has diversified and conquered the harsh environment that is dry land. As we look at the early land ecosystems of the continents, we can't help but marvel at their resilience and
Shout outs to Jordan again. You know, shout outs to Jordan.
adaptive nature. The Chytravria, Zanodendro, Tetradicopodia, Onoperatilis,
What's your favorite, chat? Comment your favorite.
Parvucormo, Size Spotters, Hanaplopodia.
I ain't gonna lie, I think Panapolodia is my guy. I really like the idea of the exoskeleton becoming like it's almost like it's in a mech suit kind of.
And Terravermis. These creatures
Terravermis is okay, you know. Shout outs to Terravermin, not my favorite. You know, it feels like you may not be the best. You might drown. You might suffocate under the earth. You put yourself there, bro.
have shaped the direction of the
Don't be
future
that
land
guy.
ecosystems. Their adaptations and evolutionary strategies have set the stage for a more diverse
Hey, this is actually a cool comparison.
biosphere to come. In the next episode, we will see how these 8 pioneering clades diversify into the countless vacant niches and fill the ecosystem with new life never before seen on the planet.
Special thanks to the fan artists on Discord who can
Yeah, shout outs to the artist here. Again, shout outs to Jordan again. Shout outs to the dinosaur dude. Shout outs to the average avocado. Again, anyone interested in sending me any type of artwork, feel free to send it to my Discord as well. I would just love to look at it. I'll figure out a place to put it in videos if you guys ever send something to me.
contributed fan art for this episode. You all have made this episode look a lot better, and your contributions to the project have been invaluable.
Hey, shout outs to Project Cemetery.
Episode look a
Because,
lot better.
again, the animated stuff takes a lot of effort into it.
And your contributions to the project have
Even for something like this where you think, you know, it's just doing that, like this takes a lot
been
to
invaluable.
animate this.
Thank you all so much for watching.
Shout outs to Kevin Spencer.
Don't forget to subscribe, like, and share your suggestions for future episodes. See you in the next episode.
See you guys in the next episode. That was a good one. I enjoyed that. I can't wait to the series to continue. And we will be continuing the series once the next episode comes out.
Good morning,
All right,
interweb.
so,
Question,
guys,
do Scott...
we are going to be watching another video at this moment. This is Sky and Plant Color, you know, with world building notes, I'm assuming. This is going to be from the Artiflexian. Interesting name here, Artiflexian. I like that. Give this guy a like, a comment, a subscribe. He's got 269,000 subs, so hopefully he subscribes to me. Crap, I could use some of that. Let me get a sub, Artiflexian. Shout out to you though. So yeah, guys, make sure you subscribe to the channel. I'm assuming we're going to be learning about the sky and plant color and why they are that color. If I'm familiar, I believe that the sky is the color because of the reflections of like the oceans, and the plants are that color because of how they absorb light. So, uh, you know the guy, you like the guy, you've seen his videos. I've never seen any of the videos from this channel before. So, hey, this might be a good thing to start doing. Should I start doing some videos like this? I don't know. We'll see how this goes. Let's see what this guy's talking about.
Skies have to be blue and plants green. Answer, not even slightly. Quick recap, starlight is a mixture of various different wavelengths of light. When light... Good morning, interweb question. Do skies have to be blue and plants green? Answer, not even slightly. Quick recap, starlight is a mixture of various different wavelengths of light. When light hits stuff in an atmosphere, these wavelengths get scattered. If that stuff is really small, shorter wavelengths of light are scattered more efficiently. We call this Rayleigh scattering. If that stuff is relatively big, all wavelengths of light get scattered equally. We call this Mie scattering. Our sky is blue because of Rayleigh scattering, and our clouds white because of Mie scattering. The warm coloured skies of twilight occur because the more atmosphere light passes through, the more the shorter wavelengths of light are scattered away, leaving only the longer, redder wavelengths of light to hit our eyes. Oh, and speaking of eyes, unless otherwise stated, if I say something is a certain colour, I mean that with respect to the human eye in an Earth-like nitrogen-oxygen atmosphere. Got it? Cool. Let's world paint. Take an Earth-like atmosphere, add warm coloured gases to it, boom, warm coloured skies. Extremely high concentrations of methane and ozone will tint a sky a hazy orangey reddish colour. Nitrogen oxide will produce an orangey brown sky. Sulfur gas will make for yellow skies or red skies depending on the temperature of the atmosphere. And there's probably a whole ton more warm coloured gases out there. Unfortunately, most, if not all of them, will be super toxic to carbon-based life forms. Alternatively, we could suspend coloured particles in our atmospheres. In 2017, Saharan dust and Spanish smoke blew over the UK, turning her skies orange and her sun blood red. Obviously a temporary phenomenon, but for something...
Wait, this happened in real life? I would have shit myself. I'm sorry. Like, I try not to curse in these videos, but I would have pooped my pants, ladies and gentlemen. I would have thought the apocalypse was here. If I was some guy in the UK, I gotta hit up my British guys now. Kyle, where you at, buddy? What happened? Were you here when this happened?
In 2017, Saharan dust and Spanish smoke blew over the UK, turning her skies orange and her sun blood red. Obviously a temporary phenomenon, but for something more lasting, we can look to Mars. Winds on Mars continually blow a fine iron oxide dust into its skies. This dust absorbs blue light, so the Martian sky is butterscotchy during the day and pinky red at twilight. Interestingly, around the setting sun, the sky is blue, which is like anti-Earth? Again, a consequence of the dust in the air. So there's two methods, coloured gases, coloured particulates. But we can also let scattering alone do the job. Take an Earth-like atmosphere, make it significantly thicker, boom, warm coloured skies. By increasing the thickness of an atmosphere, and by extension the pressure, we're essentially taking twilight conditions and applying them to the whole sky. We can very roughly estimate the thickness needed to achieve this by doing a bit of trig on the angle subtended by the twilight zone. Don't worry, I'm not going to bore you with the maths. There's a spreadsheet in the description. The important point here is that as atmospheric thickness increases, the sky will get redder, brightness will go up, and saturation will go down. That is to say, very thick atmospheres will yield pale, desaturated, reddish skies.
But I feel like that wouldn't be good for us, right? That's not good for like humans.
Lastly, the easiest solution is perhaps to vary the star. Sky colour is also dependent on stellar temperature. Cool, low mass stars will output most of their light in the red, massive hot stars will output most of their light in the blue. So the bigger the star, the bluer, brighter and more vivid the sky. The smaller the star, the redder and dimmer the sky. Basically, this.
Getting a little big there.
And that's it.
Well, the sun's kind of big there, guy. Might want to calm down there.
Some argue that this is wrong, asserting that regardless of stellar class, skies will always be some shade of blue given how dominant blue scattering is. Kind of like this. Basically, choose at your own peril here.
I choose the first one.
Assuming the first scenario, the transition zone between K and M stars will yield whitish skies. The denser the atmosphere, the purer that white. Oh, and clouds on such a world would reflect any unscattered light, thus appearing yellowish or reddish. A sky full of large colourless particles.
I'm not gonna lie, having a sky full of like yellow, pink, and orange clouds, you know, would life be that bad, you know?
Will also appear whitish, as Mie scattering will dominate. Heavily polluted planets could have milky, whitey, grey skies. Or, more obviously, planets with large amounts of cloud cover could have permanently overcast white-grey skies. Black skies are easy. No atmosphere, no colour. The star will be a pure white colour and will be bright enough to limit the visibility of background stars. The further out a planet orbits, the more background stars would be visible. Green is tricky. Remember, high mass stars skew blue, low mass stars skew red. Somewhere in the middle then, there's a star that peaks in the green. So green skies, right? Nope. See, in human eyes, green will always either combine with red to give yellows and oranges, or blue to give cyans. Even at peak green, there's enough of the other wavelengths about to prevent a pure green sky colour. That said, alien eyes could work differently. Coloured gases are of course an option. Chlorine would tint the sky a yellowy green colour, or at high enough concentrations, a yellow-green-black colour. See, chlorine is a really good absorber of light, so the more chlorine, the darker the surface conditions. Oh, and it's super toxic, but it could work. We could do a Mars, invent some green dust and suspend it in the atmosphere. If not dust, then maybe airborne plant life. Think sky algae or sky plankton. Introduce bioluminescence and your sky will be a green tinted acid trip. Think biologically created auroras.
Should we try this on Earth, ladies and gentlemen? Should we put a bunch of plankton, bacteria, creatures in the sky just to see if we can turn it green? Now, I would be a fan of a green sky. I feel like that would be pretty cool to see one day. Would it be worth it? I don't know. I don't know if it'd be worth it. Although I like the idea. One day the sky was yellowish. That's crazy. Like, would you, like, you go outside? I've seen the yellowish sky before, but I did think the world was ending or something. I saw it. I was a kid. I was like, what the hell? What is going on here? What are we doing? Should we be out here? Should we go back inside? I stayed outside though. But again, let me know if you agree with putting a bunch of plankton creatures in the sky just to see if we can turn it green. You know, as long as people on Earth know what's happening, I don't think we'd care. I think we'd be cool with it as long as we knew it was going to happen. Like, Thursday, the sky's going to turn green. You know, we're just testing out some stuff. People be like, you know, I don't really like the government, but I do like green skies, you know?
Auroras provide temporary coloration. When charged solar particles hit the atoms in an atmosphere, they excite those atoms and light is given off. M-stars are a class of star prone to massive solar flares. Solar flares mean more charged particles. More charged particles means more frequent, more vibrant, and more extensive auroras. Also, if a planet's atmosphere is packed with neon or sodium gas, say, these auroras will be orangey red or yellow, respectively. And finally, there's the green flash. When conditions are just right, the sun flashes green as it sinks below the horizon at sunset. On Earth, this effect is really rare and fleeting. But if a planet rotated at a much slower rate, this green flash could become more of a nightly green glow. Think Pirates of the Caribbean, except way less extra.
Hold on, I feel like the Green Flash. I don't think I've ever seen the Green Flash.
Caribbean, except
this might be the only moment I've seen the Green Flash.
Way less
any
extra.
moment it was in this movie here, and like I don't know what it looks like in real life. I'm sure it doesn't look like this though, right? Like there's no way it looks just like this, right?
So shorter wavelengths of light are scattered more, right? Then why is our sky blue? I mean, violet light has a shorter wavelength than blue light. Shouldn't our sky be violet? Turns out it kinda is, we just can't see it. That's because the sun emits less violet light than blue light, and our eyes are not as sensitive to violet as they are to blue. So where we see blue, an alien may well see violet. In 1950, the sun over British Columbia turned to, quote, various shades of blue or violet, end quote. The culprit? Forest fire smoke. Same shtick happens with literal blue moons.
Oh, like once in a blue moon. I get
Diurnal
it now.
cycles aside, wouldn't it be cool if sky colour varied regularly and predictably? Kinda like our sulfur atmosphere from before. Yellow skies in winter, red skies in summer. Assuming of course the correct temperatures are hit. But another cool solution is to have an Earth-like world orbit close binary stars, where each star differs significantly in mass, aka temperature. So, as they eclipse one another, the sky would subtly change colours. Perhaps pale blue to white to pale orange. Anyways, on to plants. Remember, stellar output peaks in certain frequencies and colours. So we have two floral options. Plants that are the same colour as a star's peak output, or the complement to that colour. Like if a star outputs predominantly in the blue, plant life could either be bluish or yellowish. Yellow plants are kind of saying, okay, I need starlight to live, so let me take in the most starlight I can in the most efficient manner possible. Whereas blue plants are saying, look, all that peak radiation may be damaging to me, so I'm going to block it and just feed off the other wavelengths instead. Both strategies could potentially work. Here's a rundown of strategy A.
So wait, on Earth, it feels like the second one is the thing that most plants decide to do. We were there. Hey, look, it's us. It's a little much. It's like us in fall. This is like fall. That's actually insane.
And here's a rundown of strategy B. Is this not us? Right in somewhere around this area here? Do we got an F star? What type of sun is ours? Do we got an F star? Also, there's a colour calculator in the description, so go check that out. In both cases, I've made the plants whitish around high mass stars and black around low mass stars. Very massive stars output so much radiation that a plant will likely want to reflect back as much of it as possible lest it burn. Very low mass stars output so little radiation that a plant will want to absorb as much of it as possible lest it starve. Unless of course those stars are flare stars, in which case the low radiation output will be punctuated by bursts of massively
So if we want all black plants, we just gotta move to a place that the sun is super duper close or really, really big, and then somehow survive that. Gotcha.
increased radiation. Not good news for plant life, especially black plant life. Those plants would need to develop an early warning system, some sort of UV detector perhaps, and the ability to take cover. That might mean evolving a shell-like structure they could withdraw into, or maybe burrowing abilities, or maybe they literally move, blurring the line between plant and animal, or maybe plants on such a world would need to live underwater. the water acting as a shield. Basically a dimly lit orangey red and black swamp world. Pretty cool, right?
Kind of.
That is pretty cool, but I really like the idea of a seasonally changing sky. So let's say we have a large continent with a tall mountain range all along its western and southwestern flanks.
Okay.
The center of the continent is a giant desert, and in winter a powerful monsoon wind blows from the interior towards the coasts. There's a great city in the south, and during the winter monsoon, the sand blown from the great desert fills the air and paints the sky red. The red season is also the dry season, and as it continues, rivers and watering holes start to dry up, so the people of the city bring out everything blue they own into their courtyards and into the streets to change the color of the sky, and in the city center, atop the main temple, they turn the sacred bellows north to reverse the direction of the wind. Summer comes eventually, and the monsoon winds start to blow from the sea to the interior, bringing with them a blue sky as well as clouds and rain. Rivers fill with water, people plant their crops, and cows give birth to calves. But along with renewing life, the southern winds also bring death.
I'm not gonna lie, I was down for them all bringing out all the blue stuff. Not down for them creating a big old wind thing and just trying to use that on top of the pyramid. Like, come on, bro, what are you doing here? You're that's not effective. You know, maybe us all wearing blue, maybe the gods all see us and they're like, oh, that's cool, let's give them some water. They're definitely not doing it with the whole wind thing. They're just like, oh, what do they think? They're special? They think they're better than us? You know what? Less water. How about that? You know, it just feels, you know.
And pools of rainwater turn into breeding grounds for mosquitoes, and the insects transmit malaria and dengue fever, killing many people. And so everyone brings out their red clay pots and puts on their red clothes to banish the blue sky and its clouds, while the sacred bellows are turned to point south to call upon the desert winds. And with time, the winter monsoon comes and fills the air with sand, painting the world red, until it's time to turn the bellows again.
Yeah, I just hate that they
Good morning.
I hate that they think the bellows are more effective. Like, bro, just you're already wearing the colors, man.
Interweb, a massive thanks goes out to Eva of World Building Notes fame for collaborating with me on this video. She is an amazing creator and deserves so many more views than she currently has. So please go over there and blast her page. I promise you'll love her content. Also, massive thanks goes out to Simon Clark, another YouTuber who you will love, for helping me out with some of the science in this video. And finally, a massive thanks goes out to each and every one of you for watching this video and supporting Artifactian. In particular,
I'm not gonna lie, I kind of like that video. I think I'm gonna go ahead and subscribe to the channel. Guys, make sure you also subscribe to Artifactian. I feel like there's some more videos here we could probably watch later on. Again, I have 2 more videos for tonight. I am gonna call it after that. But I do want to see, maybe there are some rocks. That might be a good one. I like rocks sometimes, you know. Copper, okay. Making plants better. Oh. Spec Biolog. What is this? Is this like a series? Oh, it is. Okay. No.
good morning.
No, that's not what I meant to do. Okay, let's go back to the previous videos here that we had. We are going to finish out with the Project Opono. Yeah, we're going to be doing this one now. Welcome to Tacticus. Tacitus. Tacticus. We'll see how they pronounce it. Make sure you guys go ahead and subscribe. And then also, we are going to be finishing this out with Project Zira. So I meant to add that to a playlist. Hold on. This got to be a playlist type thing. There we go.
Welcome, fellow explorers, to Project Tacitus. In this
Tacitus. There we
first
go.
episode, we will go over the planet and its stellar neighbors. Our first stop is Demeter. Demeter is an F-type main sequence star with a mass of 1.1 solar masses and a diameter of 1.056 suns. Demeter has a surface temperature of 6,183 Kelvin, meaning that it is hotter than our Sun. This results in Demeter being brighter than the Sun, having a luminosity of 1.46 times that of the Sun. Demeter's habitable zone ranges from 1.15 for astronomical units to 1.66 to astronomical units. Our next stops are the binary planets of Tacitus and Charon. Tacitus and Charon are a pair of binary planets that orbit 1.4 astronomical units away from Demeter, directly in the middle of the habitable zone. We will go over them one at a time. Tacitus is the main focus of this project, being the only planet in the Demeter system to support life. It is a small Earth-like planet with a mass of 0.63 Earths and a radius of 0.88 Earths.
Okay.
Tacitus has an atmosphere quite similar to Earth's, having a similar ratio of gases, except for the lower amount of oxygen, around 19%. Tacitus also has a ring formed from its past inner moon being torn
Hey, shout outs to Blapmind. I like this
apart
one.
by its
I like this image. The Earth looks soft, but also very visible. I like the texture that I'm seeing right here.
gravity. We will cover Tacitus in much greater detail later, however, we must keep exploring its stellar neighbors. Charon is a mid-sized desert planet with a mass of 0.835 Earths and a radius of 0.946 Earths. Charon was once a lush world covered in water. However, due to its thick atmosphere, it couldn't sustain its oceans for long. Over time, all of the water evaporated, forming a thick, hazy atmosphere of water vapor and other gases.
Oh, wow.
However, water remains at the poles, although Charon is still considered uninhabitable. Tacitus and Charon both share one moon, named Pleiades. Pleiades is a large moon with a mass of 2.
Do planets share moons sometimes? I didn't know this happened. Is this like a thing that happens? This is cool.
0.1 lunar masses and a radius of 1.166 moons. Pleiades orbits both Tacitus and Charon, but not the planets themselves. Instead, Pleiades orbits their common center of mass, or barycenter. This gives Pleiades the most stable orbit around its parent planets as possible. Now that we've gone over Tacitus's stellar neighbors, let's explore the planet in greater detail. Tacitus's small mass and radius of 0.630 and 0.880 Earths means that the planet will have an overall softer gravitational pull than Earth, with it being only 0.813 times the strength of Earth's. This may mean that the creatures of Tacitus may grow too much larger sizes than animals on Earth, but are slightly held back by the lower amount of oxygen in the atmosphere. Speaking of the atmosphere, Tacitus's atmosphere is quite similar to Earth's, being made up of 79.7 to 6% nitrogen, 19.7% oxygen, 0.7% carbon dioxide, 0.93% argon, and lower quantities of other gases. Tacitus is very geologically active, thanks to the gravitational pull of both Charon and Pleiades. This results in Tacitus being littered with oceanic mountains, volcanoes, and other geologic structures. As a result, the oceans of Tacitus
That's going to come in handy later, I bet.
have several strange attributes, one of which being the isolation of currents into specific areas of the ocean. The undersea mountains provide a wall for the currents to run along, resulting in them looping in the same area constantly. Some areas are dominated by fast currents, while others are dominated by slow currents. This may pose some strange challenges for the native life forms, but that won't matter much, as life on
I wonder if there's going to be like a central current that goes around the world that kind of heats it and cools it. You know, like what do we have on Earth? We have a like a jet stream that goes pretty much throughout the whole like Atlantic Ocean, right? And I'm pretty sure it goes like around. I don't know if it connects all the way around the world, but I'm pretty sure we at least have a jet stream. There might be another one in the Pacific Ocean too. So let me know. Do the Atlantic and Pacific Oceans both have like a stream of a water channel that kind of goes through them that kind of provides stuff? I mean, if I remember Finding Nemo, for my Finding Nemo lore, there's definitely a jet stream somewhere.
The planet at this point
Those turtles were using it.
is non-existent. The last thing we must discuss are the continents of Tacitus. We shall see how the continents of Tacitus drift from the first life to the present day. I will show you how they drift now.
Okay.
The continents are named Pugna, Liui, and Sameo. They form a supercontinent
What's your favorite continent? Minus Laoya.
known as Puglaceme. Over time, Puglaceme begins to break into three separate land masses, forming a shallow sea in between the three continents. Eventually, Puglaceme fully splits apart, separating the ecosystems of the three continents. At the same time, Liui also begins to split apart, creating a new continent named Fige. As this happens, the continents of Pugna and Sameo begin to drift towards one another, while Liui and Fige drift northward. Eventually, Pugna and Sameo merge into a new supercontinent named Pugsime. While this happens, Liui begins to drift towards the equator, leaving Fige completely isolated from the rest of the continents. As Liui approaches the supercontinent of Pugsime, it begins to split once more, while Fige begins drifting southward. When Pugsime finally splits apart, Liui and Simeo merge at the equator, forming another new supercontinent named Lasimeu. Meanwhile, the continents of Pugna and Fige drift towards the poles, confined to completely isolated existences. And this now marks the end of our celestial journey to Tacitus and its stellar neighbors. We have seen the parent star, planets, and their one and only moon. In the next episode, we will discover the weird and wonderful
Hey, fairy ring.
newly evolved life forms that inhabit Tacitus' early oceans. Special thanks to the fan artists on Discord who submitted fan art for this episode. You all have made this episode look a lot better than it would have been without your help. Don't forget to subscribe, like, and share your ideas for what life forms may evolve on planet Tacitus. See you in the next episode.
I need to have a humanoid creature, if possible. Save it to the last episode, though. I want something to eventually evolve into a humanoid creature on here. That is my request for this. I just think it'd be cool. It probably don't even make it the best. Don't even make it the best animal. Just eventually make it to be humanoid. It doesn't have to be like good. You know, that's my request for this. So one last video for this stream, then I will call it a night so I can get some other things done, ladies and gentlemen. But we are here for Project Zero. They also work with Project Opono. So yeah, let's check this out. Also, let's give them a subscribe. Let's subscribe to the dinosaur dude. You know, I'm sure he's a cool dude with lots of dinosaur stuff. Let's go ahead and check this out, ladies and gentlemen. This is going to be a good one. What happened? There we go.
Alone. We are alone. According to our knowledge, we are the sole inhabitants of the universe. Earth is not the average, but a cosmic odyssey. It is frowned upon by its neighbors for harboring the miracle that is life. In our universe of darkness, life glimmers like a shine of hope. That call, a call of desperation, will never be answered, for we are alone. But what if we weren't? What if Earth wasn't alone? What if there is extraterrestrial life out there, unknown to us?
This is like that, is it like the Simon or like the Vsauce guy who kind of does music like this?
Knowledge.
I like that.
Could this exist? What would it look like? If only there was a YouTube channel dedicated to showing you what extraterrestrial life could look like. Introducing Project Zero.
Shout out to all these channels, guys.
Calm down, I know. Project Zero will be a speculative evolution project based around what would life look like on an exoplanet. But before we can make the life, we must make the planet itself. Oh yeah, I'm Zachbot. I'll be your host for today.
Hey, Zachbot.
We can't just create the planet itself. We have to create the stars, its neighbours, other galactical objects, etc. In front of you now is an image of Zera's system. Looks interesting enough.
Yeah.
Let's take a closer look, shall we? Pyre lights the way.
Okay.
Pyre is a G-type star, very similar to our Sun. It's got 1.1 solar masses and emits a large amount of red and green light. This causes the plants on Zera to be a blue coloration, as it would like to reflect the blue light and absorb the red and green.
Okay. You know what? Shout outs to this guy. I like that. And I also like the blue light. You know, I like the blue plants. I feel like blue plants, you don't see a lot of blue plants on Earth. It's not impossible. You do see some, but you don't see a whole lot of them. Like grass being blue, kind of crazy.
Castor and Pollux. Two heads are better than one.
Castor and Pollux, aren't these like comets or something? Like stars that used to be like Greek stars? Like back in the day, like people used to see like Castor and Pollux, and then it was like an omen or something, like a bad omen. I only see one of them.
Castor and Pollux were two small rocky planets that separately had their own orbit, up until a certain event caused them to get intertwined and orbit each other. These two are called twin planets, as they are constantly circling each other as they swirl around the sun. This means that if you were to stand on the surface of Pollux, you would be able to see Castor, huge in the night sky above you. Fun fact, they're both tidally locked to each other. They're both named after two twins in Greek mythology who are constantly fighting, and they do live up to their name, as occasionally they can be seen ripping each other apart and rebuilding themselves of the debris. Pollux is slightly larger than Castor, although they are roughly analogous to the size of Mercury. Both are packed with ions and other metals and minerals, which would be great for future civilizations trying to build a Dyson sphere. Zera, star of the show.
I like how we're already getting to the point where somebody is thinking about a Dyson sphere. Like, we got to see the planet first. Are they going to have creatures that can make a Dyson sphere? Are Dyson spheres something that can be made in life? All questions we're going to find out.
Zera will be the
I like this so far.
main focal point of the series. Wow, shocker, I know. It's a low-gravity world with two moons, a strange continent in the middle, and many other interesting attributes. That's all I'm going to say for now. We'll get back to them later. Yera. My mysteries remain unsolved.
Why did that almost look like a poop on the planet? That's crazy.
Yera is the sister planet of Zera. It looks to be incredibly cold and incredibly large. Something odd seems to be happening on its surface. For now, I'll leave it alone. Parvi, small but mighty. Past Yera is an asteroid belt, simply titled the Belt, and in it resides Parvi. Parvi is a small dwarf planet, so small it can't even form itself into a sphere. It instead has to deal with an odd pear shape. Okay. It's around the size of Pluto, although slightly smaller, and its surface is covered in a layer of ice. As much as I'd love to stay with Parvi, we have to move on.
Okay, we just brought it up.
Gargantua. You see moons, he sees bullets. Gargantua is the only gas giant in the system. Due to certain chemicals in its atmosphere, has a yellow/green coloration.
Okay.
Now, I ain't no chemist, but my friend is, so if you would like the individual chemicals and reactions, pause to read.
Alright, hold on. So if your gas giant has carbon dioxide and iron, copper/iron carbonate in sufficient amounts, the iron copper/iron carbon could catalyze the carbon dioxide to turn it into formic acid. Then formulation or formylation reaction could occur with glycolide. If it forms, which could happen, it's pretty simple compound, creating glycinic acid, which then could connect with another and then oxidize to make two dash 5 hyphen dexatromethylic, can form a carbon ring and then some more oxidation oxidation to make FDCA, which is green. Okay, a lot to say. If you add pretty much add iron, iron, copper, and iron carbon in sufficient amounts, it's gonna do some stuff. It's gonna turn the place green. It'll probably kill humans though. That all those things would kill humans.
Colour isn't the only thing Gargantua has going for it. It also has multiple moons. Some are planet-sized objects with lakes of methane and ethane. Some have an outer layer of frozen wasteland with a subsurface ocean. And some are just glorified rocks. Perhaps later down the line, we could take a look at some of Gargantua's moons and see what interesting life could evolve on them. Skadi, see you on the flip side. Skadi is an ice giant around the size of Neptune.
The ring is impressive, I ain't gonna lie.
And a few billion years ago, it looked just the same. Although, now we can see it has taken quite a transformation. You see, it hasn't always looked like this. A long time ago, it looked like a cross between Neptune and Uranus. Although that has changed. As of now, Skadi is the last planet in the Pyrrhi system. Although there used to be another. Uller was an icy super-Earth. An icy, desolate world far outside the habitable zone. And one fateful day, it got caught in the gravitational pull of Skadi. It quickly sped up, and eventually, a collision course was on its way. When Uller smashed its side into Skadi, it exploded into thousands of pieces, creating a ring of ice and rock around the planet. Not only that, but the impact sped up Skadi's rotation, causing a huge equatorial storm to emerge. We're not done just yet. It also caused Skadi to have a huge flip, 90 degrees in fact. So instead of looking like this, it does look like this. And that, my friends, is Zero System. But we are not done with the video yet. We are yet to go over Zira in great detail. We still have things like atmospheric composition, tectonic plates, and much more to discuss. If we are going to talk about Zira, this image just won't do. Let's enhance. Much better. This is a much better view of Zira. Here we can see a large supercontinent with 3 jutting branches, a desert in the middle, and a polar region up north. Those 3 branches
this is a desert right here, guys. This is a desert, this is polar.
Are actually their own continent. However, these 3 continents converge in the center, causing them to look like one large one. The northern landmass is Onu, the western, Duos, and down south we have Tribus.
I like the naming convention here. Uno, dos, tres, Ono, Onu, Duos, and Tribus. I would be more of a Duos guy. Maybe hang out in Tribus, but definitely not Ono. Anu. Not Anu.
Much like Earth, Zira is tectonically active. And those tectonic plates will look something like this.
Hey, I like that animation. Shoutouts to Flip a Clip. This is actually
Plates
pretty cool.
will look something like this.
I like how the animation looks kind of soft. But it's like a nice, but simple animation. And then look how it goes. Bam, 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 bam. And it comes
Unlike
back.
Earth, Azira is unique as it has 2 moons instead of the one.
You gotta
The
go to
names
bed.
of these moons
Good night, Anthrax. I'm glad you were able to join in the stream. I will also be getting ready for bed soon.
are
So I
Corda
understand.
and Canoa. Corda is the larger of the two and is roughly the same size as the moon, while Canoa is around half and orbits further. Since Canoa is so small, it can't form itself into a sphere and instead has to deal with an odd blob type shape. Both of these moons will have a large impact on the tides of Zira, giving it very large tides. This is because the moon's gravity actually pulls on the oceans of Zira. This also happens on Earth. The final aspect of Zira we must talk about is its atmosphere. It looks incredibly like Earth, with large amounts of nitrogen to form certain compounds needed for life, and large amounts of oxygen for creatures to respirate.
What's the argon all about? Am I the only one who don't really get argon? Like, what's argon do? I don't know.
There has been so much talk about life on
Jordan's laying in bed right now. Wake him up. No, I'm joking. I hopefully this will be good stuff for people to watch. Even if you want to watch my videos, even when you're falling asleep, feel free. I'll try not. I'll be extra quiet for you. I know I won't. I'm gonna talk normally, but great content to fall asleep to. One day you just put a playlist to my videos. You can all fall asleep to.
Zira.
I'll be saying stuff that may wake you up, but then you'll fall back to sleep to my voice. You'll be like, "Oh, I fell asleep to his voice. Oh my gosh, I loved it." I don't know if that's how you sound, but maybe. Who knows?
But if we touch down on its surface, we see no signs of life at all.
No.
However, that's because you're looking in the wrong place.
Yeah.
You should be looking under the waves.
Really? Always got to look under the water first for the life. That's what I'm seeing here. So yeah, you always got to look underneath the water. You go on land, ain't nothing gonna be on land at first. It's always gonna be underwater for millions of years, and then it'll eventually. Once some plants, if you see plants on the land, that's a good sign. But if you don't see no plants on that land, you ain't about to see no creatures. I'm gonna tell you that right now.
Hello guys, thank you so much for watching all the way to the end. An even bigger thanks to the people who made art for this video. If you would like to see some
Shout outs to everybody who made art for the video.
spoilers for the next episode, make some art, or just genuinely chat, a link to Project Zira's Discord server will be in the comments and hopefully description of this video. Next episode, we'll be talking about multicellular life and the first large life forms to ever inhabit Zira.
Okay.
Again, I can't stress it enough. Thank you so much for watching. See you in the next one.
Okay, guys. We had a good stream tonight. Lots of good stuff here. We've watched 2 projects. We found another video series that we might start doing later on. I might have to do some. Argon is used in electronics, I think. Is that what they use for? No, what do they use for neon lights? Is that just neon? Is that like a thing on its own, or do they use argon in neon? I don't know. Either way, guys, we had a great stream. Actually, one of my longer streams, to be honest, a non-sports related stream going on this long. Insane. 3 hours of scientific information. Whoa, call me Neil deGrasse Tyson, why don't you? But yeah, shout outs to all you guys out in the comments. I'm glad we were able to watch these projects, and I can't wait to continue them. They're all been great so far, and the fact that it all started based off of the other series that we're finishing up, the Alien Biospheres, and then leads into this. Yeah, Neon is his own thing. Okay, Neon is his own thing. He's also a completely different streamer. So if you want me to be bigger than Neon, make sure you guys donate. I don't know where that came from. I'm yapping right now because I'm a little sleepy. So, guys, as always, if you made it this far into the stream, I want to say thank you. Hold on. What's this comment here? Thank you so much for reacting to my series. Although I have posted a YouTube short about one creature I just made. You know what? We'll check that out. Not tonight, though. I really do have to go to bed. Have an alien project. I might do. Oh, Jordan might do an alien project. Jordan, send me the name of the project. Just comments on any of the videos. We will be watching it. It's not going to be bad, Jordan. I believe in you. The whole chat believes in you. Everybody believes in you. We know this is going to be great, Jordan. Don't doubt yourself. Don't put yourself in that type of light. This is going to be a great project because I haven't seen a bad one so far. So once again, shout outs to Riley, aka Project Opono. Shout outs to Project Zera. Shout outs to Jordan, who's going to be coming out with another project that's going to be incredible that we're going to be checking out on the channel. So I can't wait for that. It's 45 seconds long. Okay, Riley, you convinced me. I watched the 45-second video. Again, I am tired though, so I don't know how that's gonna affect how this goes. Let's see here. Oh wait, you're right there still. What is it? This one here?
Welcome.
This is the blue-armed hexasphere. These strange organisms inhabit the planet T6702. These creatures' strange appearance comes from their earliest ancestors who...
This isn't the AI thing anymore, voice anymore. This is like your voice now. Nice. Well, with the voice effect thing on it, yeah.
Meaning that this is the blue-armed hexasphere. These strange organisms inhabit the planet T6702. These creatures' strange appearance comes from their earliest ancestors who are mixotrophic, meaning that they both ate things as well as photosynthesized. Their 10 limbs, over time, adapted for different purposes. 6 of their limbs became legs, allowing the hexasphere to walk across the sandy seabed. Their remaining 4 limbs contain all of their photosynthetic pigment, as well as having offshoots with eyes at the ends to allow them to see their food when it passes by. Once food is caught by the tentacles, it is pushed into the mouth on top of their head, where it is then digested. The blue-armed hexasphere grows up to 10 inches tall and lives for over 10 years. They inhabit all but the coldest parts of their planet's seabed. This is the blue-armed hexasphere.
Yeah, with the voice. Interesting. I like it. All right, guys. I have to get to bed. I'm starting to get into that loopy mode here. So who knows what the next thing I might say is. So, guys, again, if you made it this far into the video, I do want to say, as always, thank you. If you participated in this, again, I want to give you an extra thank you because you know what? It takes a lot to make these projects. The amount of effort, research, and everything it takes is actually incredible. So, again, anybody who made it this far, make sure you subscribe to all the channels. I will be adding the links or the channels to the descriptions of the video. But as always,